For those who haven't been here yesterday, I'm Pavel Schneider, and if you need anything from the organizers, just look me up. How about now? Is it better? Yeah. Thank you. So before we start first talk,
all the people are too noisy.
hey, we're about to start. Thank you. So before we start, Adam just wanted to say a few words.
If you are going to hold a lightning talk later on, please contact the Orga team with slides. So just grab me in the hallway or ping me on IRC. I'm Adis Bladis. And yeah, I'm going to hand it over to our speaker, Daniel Schäfer.
Good morning, everyone. I hope you're still not tired from yesterday night. My talk is going to be on GNU Gigs and what we can learn as Nix from it. I don't want to convince you to use Gigs. Nix is pretty good, but I think it's useful to know what Gigs is. So yeah, my topics are going to be what is Gigs, how does it compare to Nix, whether it's any good, if it's compatible with Nix, like if you can use both, and what advantages it has, what we can maybe integrate into Nix. So who of you has heard of Geeks? Okay, and who's actually used it? 4 people, okay. So me and Geeks, why do I talk about Geeks? This summer I finished my bachelor's thesis, and then NixCon was announced, so I thought, hey, I know a lot about Nix, I could do a talk. But I didn't know what to talk about. And somebody in Discourse, they wrote, it would be interesting to know about Geeks. So I thought I could try Geeks and tell you guys about it. So what is Geeks? It's a functional package manager. It's also a distribution with 100% declarative configuration, which does transactional upgrades and rollbacks, and unprivileged package management, so without root you can install packages. This description might seem very familiar to you, but Geeks is not a language, so there's the first difference. Yeah, how do we come from Nix to Geeks? It's basically another implementation of the ideas of Nix and NixOS. So if you read Elko's thesis, or if you like the ideas of Nix, then Geeks would appeal to you. But it's not just an implementation of the ideas, it's pretty much a re-implementation of Nix packages, and NixOS. So it's not a black box re-implementation, but with knowing the details. So even as a user of Nix, if you know the commands, everything is going to be really familiar to you. It's going to have different names, and the libraries are different, like the standard library they use to configure their packages, but it's very similar. Feels like a re-implementation in just a different language. And to go even further, one part of Geeks, their daemon, is just basically a fork of Nix daemon. But they now modified it a bit and it's incompatible because they have a different built-in, so it's not Nix daemon anymore. Yeah, but really what is Geeks? It's really just NixOS with a different user interface, like different user experience. The commands are named differently, the language is different, but it feels like Nix. But still, all principles still apply, everything you love about Nix is there. But other than they're working on herd support because it's a GNU project, and they wanted to be the real GNU system. So that's why they call it the GNU system. It should be like the GNU project's ultimate operating system. Yeah, they don't use Nix, they use their own language, Lisp, which is the GNU's, Guile, which is the GNU's Lisp. Of course, the bootloader, they don't write in Lisp, the kernel, they don't. But then the init RAMFS, the init RAM disk, they do write in Scheme, in Lisp and Guile, which we do in Bash. And then even their PID1, they also write in Lisp. The Geeks daemon, like I said, is just a fork Nix daemon, but they also want to re-implement it in Guile. But it's not very important, it's just an implementation detail for them. It doesn't really matter that much, so it's not too much of a near-term goal. The Geeks command line tools, they're also all written in Guile. And the service configuration also, because also the init daemon you can configure using Guile. And then their package definitions, they also write in Guile. And other than we don't really write it in Nix, we write it in Nix/shell. Like you all have a lot of bash interfaces, so it's not really pure Nix what we do. They write their phases and even their wrappers in Lisp. So here, for example, is the X wrapper. Maybe you can understand a bit. Setenv, it sets the environment variable, and then it basically runs X with some configuration and the environment variable. It's not the real one, it's simplified, but just to give you an idea that they really do everything in Lisp. Okay, what kind of Lisp do they write? You maybe know Lisp from computer science classes, but it's different. They don't use a Lisp which is based purely on lists, so it's not littered with car, cadre, and all these weird functions. Yeah, in their manual they write, please use appropriate data types, don't do everything with lists. They have attribute sets and records and actually useful types. Yeah, because they didn't build their own Lisp, they use the Guile. They already have a mature language with a huge ecosystem, a debugger, for example, yeah, which is useful if you want to start something from new to use something existing to build on top. Yeah, Lisp is also untyped like Nix, but their attribute sets, they are like Haskell records. You have to build them, they must be complete. In their manual, they require that every top-level function has to have a docstring, which is pretty cool, which we don't always have. And they mandate that their Lisp is written in a purely functional style. The language doesn't mandate it, but their style guide does. So you could say they also have a purely functional language. Yeah, it even has pattern matching. With the Lisp macros, you can do everything. Yeah, and because they have Lisp, they can change their language easily. We are stuck with our language. For example, now we have the RFC45, where we want to remove the unquoted URL type. But for us, it's really hard to remove because then we break the language and then nobody can use old code if they have the new language implementation. But for them, the language is just a library. One advantage that I found is that you can really easily find definitions. In Nix packages, I often have the problem, where is this Nix function defined or where is this shell function defined? It's not easy to find, but with Lisp, you can just recursively search for the name and grab define, because always define isn't the same line as the name. You can really easily find the definition without much structured searching, just scrapping. Yeah, what things is Geeks focused on? Because it's a GNU project, it's very GNU-y and FSFy, so they don't have any proprietary software in there. They also don't have any mentions of proprietary software. It's all very strict. So they don't have Firefox, because Firefox uses some trademarked images from the Mozilla Foundation. One other focus they have is to reduce the binary bootstrap. There's the GNU Misc project, and they've achieved to reduce the bootstrap binaries from a size of 250 megabytes to just 120, which maybe we can take some inspiration from and try to reduce our bootstrap. They're also very much focused on reproducible builds. So they have integrated into the Geeks build command the rounds option to say I want to build this package 5 times, and then check whether all of them are equal. And also Geek's challenge, which if you build something locally, you can challenge a binary cache and then compare whether the outputs are exactly the same. So you don't have to necessarily trust your binary cache, you can challenge it and see whether it's actually trustworthy. And also they seem to focus on science. So their two best contributors work for the French Computer Science Research Institution, INRIA, for high performance computing. And the other one on medicine and molecular medicine lab in Berlin. And they try to use Geeks not just for computer people, but also for medicine researchers. Okay, how does it compare to Nix? That's what we really care about. We don't want to switch to Geeks. We want to know what's the difference, what can we maybe take. So here's a quick overview of some things I already listed and some new things. For the daemon, they basically use a Nix daemon, which is a fork. Language, we use basically Nix/shell, and they just use Guile. They also have a distribution. They don't use systemd, of course, because systemd is bloated and everything. Their license, of course, is GPL. They used to use Hydra. Now they built their own thing, which is called Keras. They got their store at GNU/store. And interestingly, they don't put their temporary files also under /GNU, but under /var. And interesting is their documentation format isn't a docbook, but TechInfo, which we've had recently some discussion about because docbook is very complex and not easy to contribute to. Many people probably don't know TechInfo, but it looks like it's easier to learn, at least. So the GNU Shepherd, their systemd replacement, it's not really anything special. It's looks like just another System 5 init. Yeah, it doesn't have as much functionality as systemd, but it's pretty usable. For the configuration, they don't use bash or shell scripts, but a Lisp configuration, so it's, at least I think, less prone to breaking. And yeah, they don't have all the functionality integrated, but they can use, for example, for socket activation, the inetd daemon. What I noticed is that, or what I was missing, they don't have journald, but just syslogd. So the cool journalctl commands don't work for the services. It's harder to find the logs of a particular service. Okay, this is what their operating system configuration looks like, which would be our etc Nix configuration, which is like an attribute set called operating system. And then there they define some attributes, like the host name, time zone, locale. Yeah, they can do everything we can, bootloader, file system users, and then the install packages and services. But they don't have modules. Everything is a service for them, which I'll come back to later. Okay, here is some example for the file system. Yeah, the file system is also just an attribute set. Maybe you can recognize it if you ignore the parentheses. But what they don't do is modules. So they don't have multiple files that just get merged together. Here you explicitly have to combine your file systems. So you have the base file systems, which are proc and sysfs and things like this. And you have to mention it and then add your own cons, your own file systems. So it's explicitly combined. It isn't just merged from somewhere defined in Nix packages. For the services, they do the same. So we append to the base services. They also have predefined desktop services where you have everything you need for a desktop. Yeah, there's nothing else you can do. There's no module that you can import that can do just anything. Everything else that you want to do is via a service. So a service is almost equivalent to a module. So if you can't just merge from anywhere, how do you combine things? For example, the Shepherd defines all the services, all the system services. If now if dbus and udev now want to create both the servers, they can't modify the shepherd because you can't just merge inside of it. So what they do is extend the services. So dbus says, I want to extend the shepherd with my own system servers configuration. And udev does the same. And then shepherd does the logic for combining those. So here, for example, is the Apache service. What it just defines is its name and the extensions. So which services the Apache extends. And Apache, it's also simplified, it's not everything. Apache has some shepherd service. And yeah, we just say extend the shepherd with our Apache services. And because it also uses some accounts to run those services, it extends the account service type. So the account is not really a service, but in NixOS speak, it would be a module. Yeah, and then every service that's extendable defines compose and extend. So if you want to define your own Apache virtual server, you extend this configuration. And compose defines how these different extensions are combined. So here concatenate is just, we take them all and put them in a list. And extends, you can define a function, how to take this list and transform it into the Apache configuration. So nobody can just come and import a module which arbitrarily redefines Apache. Apache has control over how you can modify it. And this is how you define a package. So it should look very familiar to you. You define the name, pname for us, version, and the source, which you fetch from somewhere, a tarball with a hash. You have a synopsis, a description, homepage, license, and everything. But what they have is, here you don't see make derivation or Python packages make derivation. You have how it's built here in an attribute. So here they say this package is built using the GNU build system. If it was a Python package, it would be Python build system. So it's not, the build system doesn't define the structure of the thing. It's just another attribute inside. So all different packages for different languages, they look the same. They're just modified from the inside. And overriding is also very easy. You just declare another package and inherit from a different package, which just takes all attributes from the other package. And then you can override anything you want. So here we just use GNU-TLS with an older version of Guile. And we override the inputs with a different Guile. But here we also don't just implicitly merge. We take the inputs of the old GNU-TLS and we delete in that list the GNU-TLS that was there and replace it with our own. So everything is very explicit. Yeah, they have lots of builders, so it's very new, but they seem to be very mature already. You can build all of these. They even have Linux module, so you can say Linux module and it automatically defines the environment variables that the Linux build system needs to install the modules into, which we don't have, I think. We need to define those ourselves in each new module, which we could do and remove this redundancy. So how they define these different build systems is, this, for example, is Go. They just modify the phases. So everything is the same. The Go build system just modifies the phases. It does something before the unpack. It deletes the regular GNU bootstrap. Go doesn't have configure. Some other things. And it replaces the build with Go's own build function. And does its own check and install. Yeah, but is Geeks any good? Is it as good as Nix? We know Nix is really good. You can use it for everything, for your laptop, for servers. But what about Geeks? What I noticed when installing was that there's no NixOS generate config. So it doesn't detect what's on your system and build a config from that. But they have a graphical installer. Well, not graphical, but N-curses based. fish or any different shell works pretty well. In Nix, if you define your user shell as some other shell, you have to do some other configuration to build to make it usable. And also in their Nix shell equivalent, and a different shell is launched in the subshell. In Nix, if you have a different shell and you call Nix shell, you're back into bash. But Gix reads your shell variable and launches that shell inside. They also have a PS1 indicator, so your command line says in the front that you are actually in a Gix shell. Yeah, there's no rebuild test, so you always have to rebuild switch, which usually I always test because I make so many changes and I don't want to litter my bootloader, and yeah. They don't have user bin env by default, only bin sh, but you can really easily configure it. They have no package maintainers. There's an attribute for the package thing to define a maintainer who maintains this package, but they don't really use it. There's 6 usages of it, and all of them are defined to bug-geeks/@gnu.org. Okay, some limitations. What was the worst for me? They cannot put the root file system on LVM. They have encryption support with looks, but no LVM. Otherwise, I would have installed it on my laptop. But it seems really easy. In NixOS, I think it's just one simple command in the init file system, in the DramFS. But yeah, nobody cares. Somebody tried 4 years ago, but didn't go anywhere. Also, you cannot build a package or run a system test without compiling all the Geeks modules. And on my system, on my laptop, it takes half an hour. So they can't really have out of tree system tests. If you import a module, like the not system module, but the Guile module, and it has a syntax error, for example, a missing parenthesis, it doesn't give you any error. It says module not found, which is not very helpful. Yeah, they have, like I said, all free software, so the Linux Libre kernel without the drivers, proprietary blobs. So yeah, if you're full into free software, it might be good for you, but otherwise you would have to define your own packages. Compatibility. Yeah, the source is not compatible, obviously, because it's a different language, but you can't also just take a single package definitions and maybe integrate it into Nix, because they have a different standard library and everything. It depends on the entire ecosystem. Then the next layer, they have an intermediate representation between source and derivation, a bag. I haven't looked much into it, but we don't have this. Oh, this should say derivation. Oh, not. Ah, okay. I added last minute. Yeah, the daemon is not compatible because they renamed some built-ins. So you can't use just their command line tools with our daemon. It doesn't work anymore. Also, the derivation doesn't work because the built-ins, yeah, they don't really care about compatibility anymore. Also, they renamed lots of environment variables from Nix to GNU. Yeah, just for branding. The output, yeah, this is compatible because it's just a file system tree. So maybe we could call Geeks from Nix and integrate it that way. Okay, what can we learn from Geeks? It's a unique name. It's much easier to search for. If you search for Nix, you mostly find Unix things. For example, the Rust crate, which is called Nix, just some Unix things. And it's also much less funny if you're Dutch or German, because Nix means nothing. And you can say, what are you doing? Nix, I'm doing nothing. Yeah, they have a graphical installer, which is, I think, even better than their command line installer. Yeah, we should do that for our new users. Well, what they can do is, Geeks environment is their Nix shell equivalent. They can go into a Nix shell with the dependencies of a program, the build dependencies, and also add some other packages, which NixShell you can't do -a and then -p something. They have a snippet thing, so when you define a package, in the source you can say, on this source I want to run some commands. So it's not in the package that you modify the source, but in the source attribute directly. So I think it fits better in the source rather than all of the package. They even have a SE Linux policy, which we've discussed recently, and there's also an RFC. But they say it only works for foreign distros. So we want to do this. Yeah, they already have it. Maybe we can take some inspiration. They can replace their phases without deleting the hooks, which we can't because they are in the shell. They can do native compilation for foreign architectures. So they can do cross compilations, but they can also compile for different architecture by putting the compiler inside QEMU, which is integrated into their command line, which is really cool. It's slower, but for sometimes might be useful if cross-compiling doesn't work. Their NixShell has a -- container, so you can have a NixShell inside a container. You can even say, I don't want network in there, I don't want anything. Yeah, which is pretty cool. Lots of people ask, lots of newbies ask, my NixShell has all these things for my environment. Why does this happen? I thought NixShell was pure and completely isolated. With this, it's much more isolated. They can build their system, not just build a VM image out of it, but build a container, like Nixos rebuild container. Python 3 is already default for them. For us, I think it's not. So they are already in 2020 with the Python 2 deprecation. Yeah, graph, quickly, I don't have much time. Graphs is basically you can replace a package with a patched one, and it rewrites all dependencies without rebuilding them. But yeah, by rewriting all the binaries and everything. Obviously, it only works if the name is exactly the same because they're rewriting the binary. But it's, I guess it's cool for some, if you don't want to rebuild everything, if you just want to quickly patch something. What they have is Geeks Pack, so you can export a derivation as a tarball. And then you can just, on a different distribution, you can just unpack it, and unpacks it in /GNU, and you can run it. You can also export it to Docker or SquashFS. But the problem here is it has to write to GNU store, so if you're not root, it doesn't work. But they have a relocatable option, which just puts it into the namespace, and then you have it under /GNU/store. And if you don't have root or no namespaces, it uses proot automatically. Yeah, what we can learn also is they have lots of translations for the manual and even description of the packages. And their command line, I think, is more integrated and more opinionated. Yeah, Elko talked about yesterday that with the Nix2, we have Nix2 with the nice command line, but we also have the other tools. And we should really move those tools into one, so we have something integrated. Yeah, they have an official code formatter, which we have some, but not official. Yeah, unified command line. They have Geeks deploy integrated into the command, like we have NixOps. They have Geeks lint, which lints the packages, so it tells you, it checks the best practices. And they have Geeks import to import packages from somewhere, so you can say import PyPy, this package, and it creates a Geeks description of this package. They also have Geeks import Nix, but it doesn't really work anymore. I think they just don't care. They also have Geeks refresh command, which is like RYNTM. It checks the upstream of this package and then tells you if there's a new version, and also tells you the new source code for it. Yeah, the lint does even CVE checking, which is really cool. Yeah, the food to Nix or to Geeks has lots of things. The Geeks refresh can also fetch from many sources. Here quickly, Elko yesterday mentioned some problems about the Nix channel. Like the channel cannot be a Git repository, you cannot pin a channel, and you cannot have inter channel dependencies. With Geeks, everything of this is possible. So maybe we can look at this and see if compared to Flakes. Yeah, like I said, it's basically the same, just the commands have different names. Yeah, summary, NixOS, Geeks is NixOS with Lisp instead of Nix and Bash. Service composition works differently, so more explicit instead of implicit merging. Focus on free software. Yeah, just like Nix, it's a small community. Much smaller, but they're dedicated, they really keep it moving. And for me, at least, it was a nice and refreshing break from Nix, like the same ideas, but just in a different way. And maybe, I think you could all try it, and often people say, learn this language, not just for using this language, but for getting the ideas. Thanks.
Few quick questions.
Yeah, so I noticed in your Go example, you're completely lacking any kind of dependencies. How do they typically deal with this kind of things for when Geeks import doesn't support the language infrastructure?
They usually define all the language dependencies as their own packages. So the Go dependencies you also specify in the inputs. They don't do this, they don't try to do everything. They break up each dependency into one Geeks package.
But how? Like, do they do code generation for these kind of things? Like, what if Geeks import doesn't support a use case?
If it doesn't support it, well, it doesn't support it.
Understood my question.
No more questions?
I wonder if GUIX has some analog to Nix configuration modules which allow to customize packages, like for example turn on or off some video codec for a browser, similar to Gen to use flags for me. Because I saw its source code and I didn't see anything like that, unlike Nix.
You can override the package and just say, yeah, they don't have overlays. So what our use flags would be is the overlays where you can just modify all your Nix packages and replace the package. But otherwise, if you just want to install the package in your environment, you can override the package like I showed earlier.
So you have to explicitly set these build flags which
Yes.
defines this.
Maybe somebody could define a service which puts this overridden package into your path. So you don't have, not everyone has to do it for themselves, but yes, it is explicit.
Okay.
So I was wondering, how do they manage different language ecosystems like Python or Haskell? You mentioned that you can import from Hackage, for example, but how do they structure that, and how do they generate existing dependency modeling and stuff?
If you do the import, it generates the package definition, and then it doesn't do it recursively, it doesn't do it for all the dependencies. In this package definition, it just says these are the, if you have Rust package, these are the Rust dependencies. And then for each of those, you have to run Geeks import Rust.
Thank you.
So you mentioned that half-hour compilation time for rebuilding geeks, I guess. So wonder when does that happen? Every time you do a Git update to get the latest geeks? Or
Yes, every time you Git update, you would have to recompile all the modules. There is an interpreted mode, but people told me it's very buggy and I shouldn't use it. With the new Guile version, there's a JIT compiler, so maybe that's better and faster.
If anyone's interested, I have a Nixos module which installs geeks on your system. So you don't even have to install it manually.
Yeah, there is a pull request for a module, and I'm in the process of improving it. Yeah, so you can use. I'm using geeks on NixOS also.
Hey, I was wondering if you had a look at how their community is organized, if there's any like differences to how the Nix community is organized, if there's any conferences, if there's any working groups, how they kind of like, yeah, how they work.
Yeah, I've got a backup slide here. Usually they're always at FOSDEM and do some talks there, and here's how they organize themselves. So for code, they host it on Savannah, like all GNU projects, almost. Contributing, or really anything else they do through mailing lists. So they have a patches, bug, info, development mailing list, and then for everything else, just IRC. They have some web interfaces for the mailing lists, but they're only read-only, like just too pretty to read it. Before FOSDEM this year, they had a small Geeks Days, which is an unconference, so maybe a small gathering, I don't know. Thank you. Importer for Rapology anymore because they changed the interface. Okay.
Let's take 10 minutes. we have Tomáš to talk to us about from local dev to production development environment for full stack project.
Hello, hello. Cheers. So I was going to build a small project with a friend. It's a transaction platform for selling and buying houses. So there are some constraints and requirements. We need a chat. We need file upload. We need actually quite a few chats. The platform is a little complicated from the communication perspective. Oh crap. And this is basically some of the requirements, like the main ones that we need to integrate. So as you see, the notifications and chat is probably the most important one. So a little context. There is no much users there. The traffic is very low. We rely only on notifications. And the idea is that we need to deliver notification fast, and it must be reliable. Yeah. So basically, we cannot lose people. So the reliability is the key. This is the bootstrap project, so we don't have any money to back it up. And we need to focus basically on reliability and on product itself. That's why I decided to use Nix for building that. So, of course, right? And this is basically a case study how I use Nix in this specific project with this specific set of requirements. So, nothing really fancy. Here's my contact details if anyone want to talk after. I will shoot it later as well. So yeah, I'm repeating myself all the time, but reliability is the key. So to achieve that, I thought maybe it would be really, really nice if I have all the environments exactly the same. It will save me a time to test on other environments because I will have as much as I can the same. And that was the point that I thought it will be I will achieve, which is kind of true. The last one, of course, is not the good thing. It's kind of what happened, and I was kind of okay with it. So because I produced this, let's say, configuration to have all the environments the same, that was less code, less different parts, less moving parts, and it was kind of working for a long time. I will tell more about later. So what are the building blocks of the projects? So that's basically Django, PyTest for integration test. Do we have like a lot of Python users here? Okay, there are a few. At the beginning, I used Vue.js and then switched to React. I will talk about this later as well. So the folder structure is like dumb simple, right? We have fixed pinned packages for Nix packages. I have packages and services, which is obvious, and the dev machine. I have Makefile, which simplify my workflow. The services is also that simple. There are basically NixOS modules that I integrate, and that's it. With packages, we have a little more, because to achieve reliability, I need to install like quite a few more tools like OpenJagger, with Cassandra as a backend, plus some other stuff like Prometheus. So there is a few more stuff here. Okay, that's how it looks like from the operational perspective. The gray ones are production ones. They are deployed to every environment. The red ones are also production environment. And the yellow ones are only local development environment. So I said I would like to have as much as possible the same configuration, which is true, and the yellow parts are basically the difference between the development environment and staging and production. I have just a feature flag to enable them, and the red ones are basically behind some password. Of course, for local development environment, I put everything into VM. I use QEMU, and that's my flow. So coding, deploy, running tests, or manually clicking in the browser. This is kind of cool, but also it's slow, right? Each time I do deployment, I need to rebuild Nix derivation for the system and deploy that into the VM, which is quite fast, but is still a few seconds. The production deployment is very similar. On the left, you see the machine Nix, which is the description of whole environment, how to build Django service, how to build Prometheus, how to build database, whatever. And then I have two small, let's call it shims, local development or machine description. Machine description probably should be called prod, which configures the machine and enables the global flag to enable or disable the local development tools. And for each deployment, I have different tool. So for production, I use NixOps. And for local development, I switched to my own tool, which I will talk later in the lightning talk. And probably will transit on the other tool as well. So right now, it's two tools. So if I want to work locally, I just do make VM dev. It will build me the QEMU. And this is basically, on this diagram, we have local development Nix, which is configuring the machine Nix. And this is this file. So if I need, I have some debug flag that I'm taking from the environment. And then I configure the machine. And as you see, there is not much, few options, and then we are good. So here is basically the deployment on production. It's almost the same. It uses the same 4 options. And production is using NixOps. And this is how I import the module. As you see, I'm providing Nix path to the project name. So I can kind of use absolute path to import the module. So I have exactly the same machine Nix description on local development and on production. The one cool part that I could achieve with this description was generated credentials. Almost all credentials to I think all credentials that are not for external services are auto-generated on the machine. So I really don't care by moving the same description or credentials from one place to another. Each time the machine boots up, the credentials are regenerated and services are restarted. So this is pretty cool. Of course, it doesn't scale. It works well so far. We didn't have any crap on production. And it's still slow to iterate. At some point, it started to be pain. And this is how the machine description looks like. There's some, let's say, global configuration options. So probably the most important are 3 first, right? To enable like crazy stuff. Here is the configuration of this is the same file, machine Nix description. This is if I want local development, this is how I configure it. I have a bunch of crap that can help me with local development and make lives easier, which is opening the firewall, changing the password of the root, and this kind of crap. This is how I generate credentials on the machine. It's pretty fun, but it works. This is how I configure credentials also in Nix module. I never pass the credentials. I think we had some discussion over GitHub. We are slowly changing. I think some of the packages to this model as well, so we don't pass password which will land in Nix store. Here's the same for Django module, and this is the tool that helps me with local development, which is PGWeb. It's basically a front end for Postgres. So yeah. So what do we have here? Python building is pretty fast, nothing magic, copying the files. Styles I'm building with SCSS, which takes like 10 seconds, but I don't change that very often. I have it's pretty stable. To minimize the build time at the beginning, I really wanted to avoid Webpack. Anybody has any relation to Webpack? Build any web package? Yeah. I really want to avoid this as much as I could, so I just linked Vue.js into the project and tried to not compile anything, just put the pure JavaScript there and leave it with, which gave me the time 10 seconds for the local build and deployment, and this is basically the iteration time, which was quite fine for me for a long time. A few lessons I learned from building this machine Nix stuff. At the beginning, I have put this development environment switch into different modules, and I was passing this flag down, and this was really terrible to maintain in the long term. So at the beginning, when I was writing it, it was really great. I remembered when everything is, so it was cool. But after 2 months, I started forgetting that I have to enable this flag there and there and there. So I really recommend to switching to the simpler model, which you have your packages at the top, and you are configuring development tools also at the top level. So if you consider this one, what I was talking about is like, for example, PostgreSQL init or PostgreSQL were half gray, half yellow, right? And what I simplified was removing those def from the packages itself, from the modules itself, and basically put any configuration at the top level if possible. So as we can see, those are my commands. There is few called local ones. They were added later because React came. Vue.js was not that great for me at the end. I think React is a little more flexible, so started doing a little React as well. And then I had to do Webpack, yeah. And also, the iteration time for Webpack is not that fast. Like 10 seconds is not fast, but with Webpack is even a lot worse. Especially because I try to use TypeScript there, and this basically takes time to compile, especially if you misconfigure it like me. So yeah, it was maybe 30 or 40 seconds to do the iteration. So then I thought, okay, let's try to maybe break a rule, or at least modify it. We know that requirements change, like this stuff. It's always changed, it's always in move. So we have to just live with it. So series engineering ahead, we need to apply some stuff. So let's put some services outside. A lot of those tools already have like development servers for you, right? Probably you know it. Django has its own server which does a reload. Webpack does a reload, hot reload. So yeah, we are moving stuff outside. So we have Django, we have Webpack. PyTest is a little strange because it's not a service. Potentially it can have a watcher, but let's address it later. So if we put out, of course, our services outside, we need to have addresses for the VM and stuff, and also credentials to the databases which are inside the VM. So for front end, we don't need that, so it's only like run the server, webpack, hot reload server, and that's it, which is that. And for PyTest or Django, I have this small script, fetch details, which basically goes cut all the run keys environments. So I have them locally outside of the VM, and then I can use them to run the test or run the Django. Yeah, that's how it looks like. I just SSH into the machine. That's basically line 15. You just SSH to the machine, get the IP address, and dump all the credentials. Okay, so we have Django running with local Nix, let's call it shell. It's not exactly shell, but Nix environment locally. We have React working. As I said, tests has no need for server, but it could be faster. Like each time I run the tests, I thought, okay, if I have reload for Django, if I have reload for Webpack, they are pretty fast, much faster than 10 seconds. And now the tests are slowing part. So I thought, okay, let's optimize that one. So the original Nix build for tests is like 2 minutes, something. And then each time I just want to enter to the environment, it's almost 2 seconds. Of course, if you compare 10 seconds to 2 seconds, it's a lot better, but I was still like, maybe we can make it faster. Oh, and there is also fetch credentials from the VM part, which is SSHing into the VM and getting stuff, which is another 5 seconds. So I optimized, of course, fetch creds from the VM. I'm not sure if I had that here. Yeah, probably in line 7, I have stats. When I compare, if I did this in less 10 minutes, I just cache it into the file and not fetching it anymore. So I wanted to do something like that with the Nix environment. So I created a small bash script, and it works pretty well. It went from 2 or whatever seconds to like almost instant. And what it does is it does Nix shell on specific. In my case, I think all the files are called default Nix. So it does Nix shell, so building all the environment for you. And basically, as you see, I run export, which is exporting all the environments from the shell, and I'm caching that into the file. The crap is that if anything changes in dependencies of that default Nix, you wouldn't rebuild that. So that's kind of crap, and you have to remember that. Or in my case, I just cache it for 10 minutes. So if I iterate fast, it's really fast. And if I break something, I don't have to remember if I broke something. After 10 minutes, it will rebuild anyway. I also started mobile application for that. I use React Native. At the beginning, I spent a lot of time trying to figure it out the Nix ecosystem for that one. I think there is one person, which I forgot the name, which built quite a good ecosystem around that. But I couldn't make it working with that specific React version. I spent a few days and then gave up. So what I did instead is, because React Native has also hot reload and you can develop your application in kind of a fast manner, I just try to make it reproducible. I couldn't make it working on pure Nix environment. I don't know why. I spent like 2 days and gave up and said, okay, let's use Docker for this part. And what I did, I just overwrite their internal tool inside the directory to start my React native server inside the Docker, which is this. So if I run React Native, it runs Gradle W, and then it builds stuff in Docker, mounts local directories, so there is a code included and stuff. And I think that would be it. Thank you.
Hi. Where do you pin Python packages?
Sorry?
Where do you pin Python packages? You mentioned that you're using Django. You know, you have Python libraries requirements.
Oh, okay. Mm. So I use PyPI to Nix. Sorry, is that what what you're
So
asking me?
yeah, so you're probably using, I don't know, like requests or other libraries in
Yeah.
Django. You need to, I mean, you probably need to specify which version, or you just import latest version.
Sure, sure. So I'm not using Nix packages for local libraries or local for building the product. I try to specify as much as I can on my side, which is both for Vue.js project, for React project, and for Python. I use my definition of packages, all of them. And of course, I use the tools that are generating that. For Python, you use PyPI to Nix. Did you know that? Okay. And for JavaScript, I use what it was, Node to Nix, I think, which generate me all the package descriptions, and then I import that, and I just do make derivation. I don't build pure Python package.
Any more questions? Don't be shy.
Thank you.
talks. And let's get rolling. We have about 5 of them, I think. First one is Tomasz with his Nix cluster.
Hello again. So I deploy a lot of servers in one of the companies I'm helping with Shareably. We have like around 1,000 hosts, which is relatively fine. And I use different kind of tools. I use NixOps, I use Terraform, CloudFormation, whatever crap is on Azure, and other those Google services. And they have some issues. So the big gray box is just a tool, right? And it has fixed logic for quite a few components. One of them is fine, and for me, especially the rollout or deploy strategy, which is hard-coded into those tools, it's really, really crap. I have a lot of environments which are completely different, right? So first of all, they have hard-coded abstractions. I cannot create my own abstractions, or maybe NixOps is a little easier, but still. The deployment strategy is fixed. Sometimes it's parameterized. You can do parallel or sequential, but can you inject your check for the database? Like you want to roll out your database, you have 40 servers of Cassandra, and you want to do one by one node, and it takes like 2 days. Those tools are really not good for that. And they are really buggy. Anybody use Terraform? Like hell, right? So there is few more. Sometimes you want to extend your tool, and it's not always easy. The state file is like another idea. This concept should really die. And yeah, there is more books everywhere. So the idea would be to shift this tool into library. So now the gray big box is our own tool. So basically we use the pieces from other libraries to build our own stuff. Of course, that makes it a little harder because a lot of glue and error handling is now on our side. But that's not that bad, and we can minimize it, and we can try to figure it out how we can minimize that and make it better. So what that gives us if we switch from the framework to the library approach, right? We can integrate new abstractions faster. We can describe whatever we want in the language we want. We can put our own rollout strategy. We can not use state file. And we can integrate other clouds or cloud resources much faster than tools, right? The tool is there to make the pull requests. Proper testing is like at least few weeks or months. And then you have to fork it or something, right? So if we have different kind of deployments like Cassandra or Elasticsearch, sometimes you want to restart cluster all node at once. Sometimes you want to deploy sequentially. Sometimes you want to have a health check between deploying services. Sometimes you want to just build an AMI and change the CloudFormation parameter just to update the auto-scaling set. And you really don't care about deploying through SSH itself. Like there are different methods, and those tools are not supporting them at all. So if we have those libraries, then we have a lot of glue on our side that for error handlings and logic. So how we can make it a lot more efficient. So the error side is a little simpler. So as you see in both cases, the user test coverage is the same, right? We have a little less coverage for testing tool, for the tool, but the user coverage is the same, which is basically I have the input and what is the output? Is the rollout done completely well? So so the error is fine. We write our test case for that, and we are if we want to switch from that tool, is already done. So how we minimize the glue and the logic? So I wrote those two libraries. They are really crap. But I will be developing them for another weeks, so hopefully will be usable. So the idea is to develop Bash tools really, really fast. There is few libraries like that already, so probably you can use them if you prefer. It's basically I'm demonstrating the concept only. So it's similar to Git, right? You have your whatever CTL or admin tool. You have subcommands. This is the main application. You define just description and main, and that's it, like the other scrap. And here you define the comment number 1. You define 4 options, you define description, and you run main. And then your logic for your cloud is just one line here. But I will demonstrate it in something more cool. So that was a library for Bash to produce CLI interfaces quickly. And now Nix cluster. So this is just a set of functions, mostly Bash, like this, where you have something specific sets of requirements you want to deliver. So in this case, you have Cassandra in Docker, and you have NixOS on VRSH, right? And then you have everything inside. And you can use them. You can develop your own. Those files don't have more than like 10 lines of code, pretty reusable. So how we want to implement stuff, for example. We have our main command, which is in this example the first one. And then we have sub-commands later. Okay, so we have some implementation details here. So how we do that? Okay, we have only, okay. So this is probably the most important stuff. We write one command. We have 4 options like name, node ID, Nix expression, SSH private key path. And then we source the implementation in the last line. And the implementation is really just a few lines of Bash which does the job. So instead of using Terraform or whatever, let's use AWS CLI, Azure CLI, Google CLI to deliver the cloud, Bash on local. The tools that are working, that are mature, that are delivered by integrators, and don't produce much code, make it as simple as possible, and use libraries instead of frameworks. Thank you.
Next up is Lars Jellema with what makes a Nix formatter. And I would like to remind Lightning Talk speakers to please keep a track of the timer over there. Don't run over time. Is this one on?
All right. Then, so hi, I'm Lars. I'm known on GitHub as Lucas16. I work at ZeroCal, and ZeroCal asked me about 8 months ago to create a formatter for Nix, as there weren't any good formatters back then. So I went out and did that. That was my task. And I had to wonder, how do you build a formatter? So I started with just a parser and a pretty printer, and then I had to wonder how do you determine the rules that determine when stuff is pretty. So obviously you first look at the common practices, but there are still multiple styles used. Not everybody uses the same style. And there's a few choices you can make. So one is to do very specific conversions. You just keep all the formatting that is in the original file. You fix up specific parts of ugly that you don't like, and this doesn't change too much, so you have more control. But you also need to spend more manual effort to format the file because it doesn't cover all cases. So you might still end up with mixed formats from different sources. And what this means is that the output is very consistent when you make like edits to your source file, but the output is not as consistent between files from very different repositories. So the other approach is total conversion. So you throw away all the formatting that was in the original file, and then you take a top-down approach. You start formatting everything from scratch, which is the approach I've taken for NixFormat. You might have heard about it. So this forces you to implement formatting for everything, and that also means you no longer need to think about what kind of you no longer need to do any manual formatting, so you can just fire and forget it. And the advantage of that is that it's like consistent based on the input. So if you have files from two very different developers that look similar, all the code will look familiar. The diffs might get a little larger because of that when you edit files, but there are ways to get around that. Like you can ignore white space with git diff, and it won't be as large. And the reason why this is actually doable in Nix is because Nix is a pretty simple language, and so there's few enough cases that you can actually get good formatting for all of them. There's also something you have to think about, which is clarity versus prettiness. So it's very tempting to make every piece of code very pretty by like aligning all the assignment operators, but that also takes a lot more work because a computer can't always guess what's pretty for you, but it can understand what is clear. So when the code is when code is I'll give an example actually. So in our expressions, the pretty printing library I used originally, which is used mostly in Haskell, it does this. It does the one on the left, the bad part. So it really wants to. All right. It really wants to fit as much as possible in a small space, and it will actually split the inner expression, which is just a call, rather than doing what's on the right and splitting on logical parts of the expression. So I prefer that, and that's why I had to change the pretty printing algorithm from the standard one in Haskell. And actually, what I like the best is this, because the operators and the keywords are on the left, and you can more easily scan the code. Yeah, that was pretty much the entire talk. So thank you all for listening, and if you have any questions, please come and see me after the lightning talks. I'd love to talk to you.
So next up is Yuyin Chatsky with Nix GUI, visualizing Nix scope and store.
Hello, Nixers. I want to talk about my project, maybe not even a project yet, but idea for Hackaday, although there is already some amount of working code and working application. When I started using Nix and diving deeper into the language, I thought it would be a good idea to write something which would make this task easier for others. And the more ambitious goal is to make something which could be usable as an installer. Because I'm mostly familiar with Python, and Qt has better multi-platform reputation, and it's also not hardly bound to graphical interface, and I hope it is possible to reuse models for something like nCarses. I have chosen Python with Qt. So what the GUI for Nix should look like? So I think users would expect some kind of tree visualizing the scope, the attributes, and allowing to read the descriptions and set values. Here is what Nix has. So there is a flow, and there are a few problems about this because, for example, there is no such thing as a canonical path in the scope because one thing can be accessed via multiple paths, which is used a lot in the scope. And it also pollutes outputs of Nix search a lot. So you can see in search results, for example, just Nix packages VLC and something like Nix packages libs for Qt VLC, and it's the same thing. And when you're new to Nix, it makes quite a confusion. Then there is a result of the computation, derivations and output paths in the store, and this transition is in fact irreversible. It's a problem maybe that we cannot get the state of the scope which produced the current profile. I have started with the store browser, which can currently be used to choose some profile or exact store path and see the dependency tree and different information about store paths. There is also some prototype for a scope browser, which uses Nix evaluate to list attributes and parses the JSON output. I don't yet have a good solution for this absence of canonical attribute path problem, but the idea is maybe we should just ignore okay, I will be finishing. If somebody of you have strong experience with Qt, it would be nice to have a talk, maybe to verify that my approach is good enough. Thank you for your attention.
And next up is Marek Mahut, and I believe you're going to talk about Morph.
Yes.
Sorry.
Thank you.
This mouse is super sensitive.
Okay. Thanks. Hello, everyone. So my name is Marek Mahut, and I'm working from a company called Satoshi Labs. You probably know Satoshi Labs by the company behind the first cryptocurrency hardware wallet called Trezor. And today I'm going to show you how we are using Morph for our configuration management of our Nix instances. So before I jump in, can I just quickly ask how many of you are familiar with Morph? Can you raise your hands? Okay, so a lot of people, that's good. So what is Morph? I really like the project description, which is just a fancy wrapper around the tools we are already using daily. The features, if you compare to the system, is multi-host, which is probably given. It's stateless, so compared to other configuration management tools such as NixOps, you don't need to store the state of the infrastructure, which is really nice if you are working in a team. It has built-in health checks, so after each deploy you can verify your infrastructure is running as expected, and it has a built-in way to manage your secrets out of the Nix store, of course. You can get it on this GitHub URL, and it's, of course, in Nix packages, so you can install it directly. Okay, so this is our directory structure for our Morph configuration. If you are familiar with Puppet, you might be familiar with this as well, as we borrowed some ideas from them. The main file which is called by Morph is infra.nix, and in this file we actually just import all of the files which we call profiles. So each server, each instance has its own profile. In this profile file we store information that are specific to the host itself, so things such as IP addresses, host names, but also hardware configuration, and most importantly, each of the profile files includes a number of roles. By roles, we are defining, we have a common role where we define something for all of the hosts, such as our default package set, for example. But each of the profiles has a role specific for its function. In this example, we have the role database that is directly linked to this profile. The roles are actually built from modules, so each role is using any modules. In this example, Nginx, and we are also having a number of secrets. We are using gitcrypt to manage our secrets, so it's actually encrypted on the remote Git server, but we can work with it just like a plain file. The workflow is really simple. We just execute morph build to build all our derivations for all our servers. The morph push will just copy the closures to the remote servers, and then we just deploy switches, which means it just switch the configuration on all of the instances. Interesting thing here, what it does after the switch is complete, is also running the health checks, and in case any of those fails, it is executing a rollback, so we don't have much downtime and we know how to fix stuff. And the last command we are using most often is to upload the secrets. So what this does is just take all the secrets and just plainly copy them into place, leaving them out of the Nix store. It restarts any services that may be dependent on those files. And lastly, it's run the health checks again to see if everything is all right. Okay, so that's all. Actually, I have some time left. That's good. So that's all. Here are the demo files, and you can catch up during the lunch if you want to talk more about Morph. I was really hoping we get like a full Morph presentation, but sadly the developers did not submit the talk, so maybe next year we will get a large one. Thank you.
So next up is Alexander. I don't know how to pronounce your surname, so I'm not even going to try. But he's going to talk about running Nix on Android. Presentation, and take it away.
Hello. Test. Hello. For all of you who are found yourself staring at your Android phones and thinking, okay, I want to try running my familiar Linux stuff there, You don't have to go full Samuel, you don't have to go NixOS mobile route. There are other approaches, and other distributions pioneered it way earlier than us. You can also go hardcore, you can embrace Android, not ditch it, but recompile all your distro with Bionic. That means porting everything to a different libc. I think that's hardcore, but Termux does that. Good luck to them. You can also get root and hammer your Android installation as hard so it will start resembling your distro more than Android. That's also always an option for power users. And you can go an easier way and just use user space root emulation. And I want to tell you that sometimes the lowest hanging fruit is the ripest one. I'm gonna skip all the boring details. I will upload it somewhere and you will look it up later if you want to. I wanted to frame it as a story. This spring I wanted a lightweight travel laptop. I didn't like anything that I could buy, but I found a nice Android tablet. And I thought, why not a tablet? I don't need much from my travel device. But there was a lingering question, could it run Nix? I did a quick Google lookup. I didn't find a definitive yes. I found a lot of people with a lot of problems compiling Nix under Android, but I found this comment and it's pretty inspirational. This would turn toys into semi-computers. I love that one. But if I'm paying for a tablet, I want a tablet. I want to use Android apps. I don't want to wait until GNOME catches up with the user experience. I also love my hardware working. So I wanted Nix to coexist with Android. I also just read excellent posts by Matthew Bauer about static linking and cross-compilation, and I was like, wow, I know what I gotta do. I should I should just cross-compile Nix and statically link it on it, and it will work on Android. So I was pretty stoked. I bought a tablet, and I remember myself thinking vividly, that would be super cool if I had a working prototype before NixCon, right? Yeah, and I got it working the same evening. The biggest problem was that I had to understand first that I don't need to do anything. If I have proot, I can just rewrite access to Nix store so it looks like it is located at actual /nix/store. And I also thought, okay, I should now sit down and build a rootfs with everything required to run Nix, and it turns out we have one and it's called Nix release tarball. And I downloaded it, I prooted into that, and it worked. Wow. So this is kind of like a testament to thank you, it just works on Android. Plain over all limitations. At first it was a very hacky bash script that did everything with an intermediate distribution called Termux, but then I cut out the middleman. I forked the app so it would run Nix directly. I started cross-compiling proot the right Nix way. Then I kind of thought, okay, it just works for me, and I stopped working on that. And then one day I get a PR that rewrites my project. I mean, some lines survived, but that was readme MD, so it doesn't count. So, thanks Gershly for rewriting everything. It's now properly built with Nix, and all the hacks that I installed on device in his second PR, he also put it under Nix control, and users now have an upgrade path that is not wipe all data and reinstall it. That's wonderful. And I also just got it accepted into F-Droid, so it should be in their build queue now, fingers crossed, so try it from Android next week. For now, you can try my APK if you want to. What gives? You can install an application, it's a terminal emulator, there's a terminal, you can Nix run something, you are encouraged to install Home Manager. You don't have to compile stuff, Hydra has our AR64 binary cache, it will just get downloaded, and you don't need root, you don't need user namespaces, you don't need SLNX, permissive, whatever. But you do need a 64-bit phone or tablet because we don't have Nix built for 32-bit ARM unfortunately. It would be slow, and proot isn't exactly helping that, and there are some restrictions, like everything that uses ptrace won't work because proot took that. And remember that you are running stuff as an unprivileged user under another Linux distro, and it's not Fedora or Debian, it's Android, so everything is messed up. So don't try fancy stuff like top or maybe ping, that won't fly. But other tools work just well. I have my favorite tools there. I've typeset this presentation on my tablet. I compiled it with Pandoc. It works. So semi-computer, I think. And all my Android experience is still there. My Wi-Fi works. I really value that. But I think there's also a bigger question. What do we want to do with that? I think we have a quirky platform under our noses. It's quirky, but it's pretty uniformly quirky. And it's already in our pockets. Maybe it's the next Nix Darwin, but we just didn't explore it enough. I don't know why we didn't do that. And you're not allowed to ask questions, but I am. So, could we make my project a tad more official? I want a fancier looking host name for my files or something. Could I maybe recompile everything? That would require a lot of builders and whatever, but this could get me out of proot. And what's the actual end game? And is it worth the effort? I don't know. So please find me, ask me, or better answer those. Thank you.
I've actually built my crazy Emacs config on this stuff, and it works just great. So, but next up is Domin Kosar, and he's going to talk about Hercules CI.
Hey everyone, how are you doing? All right, you're still awake. Let's see if this works. So I'm hijacking this talk a bit. I'm sorry for 3 topics. Let's see if we can get. Please? All right, this might work. All right, so first of all, I want to just briefly mention NixOS Weekly. It's like a weekly newsletter that's actually a monthly newsletter that goes out when I have time. But you should either subscribe for news, or there is a link somewhere at the bottom of each post where you can send your blog post or whatever you have done with Nix. So it's featured there. And I think there is about almost 1,000 people right now subscribed to it. So it's pretty wide. I mean, you can get a nice audience, and you can see a bunch of posts there. All right. So getting to my third topic with the second one, I wrote like a year ago Cachix, which is a hosted binary cache, easy to use. And I don't know if you heard, but GitHub launched their CI. It's called GitHub Actions. So there is a Cachix action. If you need to start really easy with Nix and a CI, basically you copy this file into your repo. You set your keys for Cachix, and you're building Nix and caching to Cachix in like 30 seconds, which is pretty nice to start a simple toy project. And to my last topic, we're also building a complete CI replacement for Hydra. So who is running Hydra? All right, my condolences. I offer also emotional support after the NixCon. But besides that, you can also use our CI that we've been building for the last year. So I'm going to quickly show how it works. So you can click here and you can say Hercules CI and add a repo. So you can whitelist which repos build. So let me just show you. There's just one file in it. It's a bit cryptic, but you can build Linux and Darwin with this simple expression, and it built a hello world derivation. So nothing too fancy. So if we edit now, and it loads, we can start building our project. So let's see where it is. All right. So if I push it now, we should see it build, evaluate, and build. There we go. And there you go. So it displays attributes as they're being evaluated, and now it's going to dispatch this to Linux and Darwin and build them. So yeah, that's a very simple demo of it. There is the agents themselves need to be hosted by you on different infrastructures. So we provide Terraform, NixOps, Nix Darwin, and probably other things. So we're aiming to make it as simple as possible to deploy those with auto-scaling in the future and so on. And if you go to docs.hercules-ci.com, you will see instructions how to deploy those agents. The service is hosted, so you don't have to maintain it, only the agents. It's free for open source, so you can, if you have some hardware or even on your laptop, the agents are completely stateless, so you can just run it on your laptop, and when it's online, it will build things. Otherwise, it's a paid service for private repositories. And yeah, it's a bit busy with other things right now. We're rebuilding huge Haskell set, but yeah, that's it. If you have some questions about Hercules CI or Cachix or even the NixOS Weekly, talk to me later. Yeah, thanks.
Thank you, Domen. Next up is Franz Pletz, and he's gonna talk about Network D.
So hello, this one is gonna be quick, just a few what's the current state of Network D, because I did a talk at last NixCon about switching the default networking backend to Network D, but obviously that hasn't happened yet, and quite a lot of people came up to me at this NixCon to ask about the current state. So I'm gonna do a lightning talk about it to inform you what has happened and what's going to happen. So, what has happened? Not that much actually, because due to a lack of time on my part, but also what we already did is for 1909, we deprecated the use of networking.useDHCP and Network D. So it's not possible to do DHCP on all interfaces anymore if you use Network D, because that's inherently incompatible with how Network D works. What we also did is we modified NixOS generate config to not enable use DHCP by default, but only enable use DHCP on an interface basis. So only for interfaces that are available on your system when you installed NixOS, use DHCP will be enabled. What's currently on master, what Flowcleat actually did, we also removed the 99-main network unit, which was causing the main part of the trouble for every Network D user, and like most Network D users out there, disabled that unit actually. And so the reasons why it's not ready yet, it's actually more work and more questions arose than anticipated when I did my talk. There were some people who came up to me after the talk that still wanted to keep using scripted networking. And that's a problem, because Network D supports many more features, and if we want to expose them as a networking option, and people still want to use scripted networking, we have to ensure feature parity, or do a lot of assertions, and that would make the networking module even more complex. So the problem is that we have a decision how to move forward. And the thing is, we are going to deprecate some of the options in the networking module anyway, if we want to switch to Network D. And this is actually a chance to redesign the networking module as a whole. So what I'm planning is to create an RFC for like this networking module redesign, because when I was thinking about it, I got even more questions, and I wasn't sure like how to move forward. And that's actually something the community has to answer, because like I could implement what I'm thinking is right, but that's probably not the right decision for the project. So what's my plan? I would like to have network D turnkey ready for 2003. That means you can use networking.use network D in 2003 without any problems. That's the idea. For that, we need that RFC and a little bit of that redesign of the networking module. For 2009, I would like to have the redesign of the networking module in place, which would break like everyone's network configuration probably, but yeah, that's just a thing we have to do at some point. So what's coming up? So we have to create that RFC at least like before Christmas. So I would like to do a network D sprint this year. What I'm proposing is to do it in Munich at the Mayflower office, and I've already created a doodle for that. So if you have time and if you want to contribute, like discussing about what are the possible solutions for like a new networking module, I will create a post in the discourse later today with the doodle link and some of the questions I have for you. And I hope some people can come and maybe even attend remotely for that sprint, and we can create that RFC. Thanks a lot.
So next up is Robin Gloucester. He's going to talk about the NixOS RFC process, but I would like to know, is Matthew Bauer around? No, okay, thank you.
So I'll just quickly talk about the NixOS RFC process. In March 2017, Zimba, Thomas Hunger and Morty started the idea and established the first version of the process. We had a few RFCs which were really uncontroversial, which were accepted, but otherwise everything which needed more discussion. We didn't really have any way of determining if it's going to be accepted or not. So last year at NixCon, Graham, myself, Florkley and a few others sat down and wrote up an RFC trying to improve the RFC process. That was accepted in January as RFC 36, and in that created one team of 5 people who, for every RFC, select a team of people who are knowledgeable about that topic, who in the end decide. And that first team of 5 is the RFC steering committee, whose rotation was defined in RFC 43. That was accepted in June. So we have these 3 teams, or 2 teams plus the leader of the second team. The RFC steering committee is Elcor, Domen, Shay, Mick92, and me. I think I didn't miss anyone. We meet once a week and go through all RFCs. When a new RFC is opened, there there's a period where people can nominate the so-called shepherds, and the RC steering committee then selects 3 or 4 shepherds. The shepherd teams, or the shepherd team, is responsible for trying to make sure that the conversation is makes sense and actually focuses on the topic, and the shepherd leader tries to facilitate meetings with the shepherds and the author so that they can discuss points that are controversial or need further explanation. And we'd like to encourage the leaders to actually meet up with the other shepherds and the author more, so that because we've had the experience that the meetings actually bring the most benefit in the discussion and move on RFCs much faster than just commenting on the RFCs. The general process is write and PR and RFC, then there's this shepherd nomination period of 3 to 4 people getting accepted as shepherds, then a discussion until it at some point hopefully reaches a general acceptance, or generally everyone agrees that it probably isn't a good idea in the form that it's mentioned in the RFC. And then the shepherds call a final comment period of 10 days where they say we all unanimously agree that we'd want to accept or close this RFC. And then there's a 10-day period where people can bring up new points so the discussion continues, or otherwise after the 10 days the RFC is accepted or closed. Then I'm running out of time, so there are a number of accepted RFCs and open RFCs, for example Flakes, and FPLETS is going to open one on networking. And then the RFC steering committee is going to be rotated at the end of this year. We are looking for people who would like to be in it, and I'm going to open a thread on Discourse today. Please nominate yourself or other people, and at the end of the year, the steering committee will decide on the next steering committee for next year. And a few links.
And I believe that was our final lightning talk, but I would like to quickly just ask. Damn HDMI. Cool. Yeah, I would like to ask everyone to, on behalf of the Orga team, to have a look of the program and submit a review about, so a feedback on every talk that you have some feedback on. So you just go to the schedule, and on the schedule you can click a talk, and then there's a feedback button. And just write your honest feedback so NixCon can be even more awesome next year. And yeah, I know you're all hungry, so we have an hour lunch break, and we'll start again at 1 o'clock.
I had some questions. What's the plan for the evening? So we're going to a pub called Mammoth, and there's a tab at each table and the scoreboard, so that should be fun.
So I'd like to just announce that if you would like to host next year's NixCon in your city, please join the NixCon channel or send a message on Discourse, but it would be preferable to talk to the Orga team first on IRC. And also, let's just check my notes. Yeah. Also, there is a topic board for the hack day in the back on the right-hand side of the room, right-hand side from my point of view. So if you would like to work on some project on the hack day, please write that up on the board.
Hello, everyone. I'm Sam Leathers. I'm with IOHK, and I'm going to be talking about Haskell.nix today. Sadly, my colleague Moritz Engerman that wrote this was not able to attend, so I'm doing this presentation for him. So to get started here, okay, good. Haskell.nix is an alternative infrastructure to build Haskell packages with Nix. Nix PKGs does have a Haskell infrastructure already in place that is used for all Haskell packages provided by Nix PKGs. This talk will address the why and how Haskell.nix came to be. So the Haskell package infrastructure. Haskell uses a tool called Cabal for package management. Packages are annotated with Cabal files, which provide Cabal with sufficient information to discover and solve for dependencies and instruct it how to build the package. Haskell packages have to provide a library and can provide multiple named executables and named test suites. These are called components. A package can therefore have multiple components, but must at least have one. Recently, sublibraries and the ability to add named libraries have been added to Cabal. We will ignore named libraries for now. Packages can be built using either a command line tool called Cabal install or a lower level plumbing approach using the Cabal library that comes with the Haskell compiler called setup.hs. To build a package with Cabal, usually it is enough to call Cabal new build. Cabal will solve and download the dependencies. To figure out the dependencies, it relies on some form index of the current globally known package universe. This index is provided by a web service called Hackage, which is the central Haskell package repository. Using Cabal new update will update the local index with the one from Hackage. With the Hackage index, Cabal will then solve against a given compiler version for a package set to use as dependencies and subsequently build the package. So the setup.hs approach. The Glasgow Haskell compiler, this is also known as GHC, is the predominant Haskell compiler used in production and ships with the Cabal library. This is important as it allows a package to be built without the Cabal command line tool, but with just a simple Haskell module compiled against the Cabal library. This is usually called setup.hs and provided alongside the Cabal file. If not, it can be trivially created. Compiling and running this module will produce a very simple interface to build the Cabal package. It will not take care of downloading the packages. These will have to be provided by the end user. It will, however, ensure that a valid dependency solution can be computed for the package to be built given the provided packages. And up there you can see a sample setup.hs file. So the life cycle of a package built with Nix PKG's default builder. So first we're going to talk a little bit about how things are done with Nix PKGs and Haskell with Nix PKGs, and then we're going to get more into the nitty-gritty of how Haskell.nix is doing things and show some examples here. So packages built within Nix PKGs usually follow the following steps. You download the source code, apply any relevant patches, configure if necessary, you build the package, and then you run the test suites if they're available. So the existing Haskell infrastructure in Nix PKGs follows this life cycle pretty well. It builds all dependencies and uses the setup.hs approach to build the package against its dependencies, and then runs the test suites via setup HS as well. Then it marks the package as successfully built. To achieve this, it uses a tool called Cabal to Nix, which takes a Cabal file, the description of the package and its dependencies, and translates it into Nix. Then Nix can read the description and decide which dependencies are needed, and depend on them and provide them to setup HS when building. We try to sidestep dependency resolution here by providing a curated package set with Nix PKGs. Hence, any package that is being built with Nix PKGs will need to be built against this curated package set. For some packages, the curated package set may contain multiple versions to satisfy otherwise unsatisfiable constraints. So some benefits of the existing Haskell infrastructure in Nix PKGs. By using a curated package set and the GHC compilers available in Nix PKGs, the complexity of package and compiler matrix and operating system is very manageable. To provide NixOS and Nix PKGs users with pre-built Haskell packages for tools like pandoc, getannex, hackle, this works really well. Using only Cabal to Nix and a curated package set leaves the builder to be relatively straightforward and involves little complexity in Nix. By being part of Nix PKGs, it's tested on a daily basis by Hydra whenever anything touches the Haskell infrastructure. Be it compilers, packages, changes, the curated package set, it is also the infrastructure that's available to anyone using Nix PKGs right out of the gate. There are some drawbacks, though, of the existing Haskell infrastructure. Whether or not it makes sense to have multiple package sets in Nix PKGs is debatable. For the purpose of providing Haskell packages with Nix PKGs, a curated package set makes sense, though. It's tied to Nix PKG's selection of compilers. Any other version would need to be added through an overlay. Also, the compiler expressions in Nix PKGs may change in unexpected ways when updating Nix PKGs. The Cabal to Nix tool will flatten the conditionals that Cabal files can have, like the operating system, architecture, GHC, other flags, at build time. Hence, if the Cabal file was converted on a Linux machine, it will almost always miss the Windows branches, or might miss macOS branches. Hence, overriding of expressions is needed to patch back in existing library dependencies. This makes cross-compiling Haskell packages rather complicated. Cabal to Nix resolves system library dependencies of Haskell packages to their respective Nix PKG sets within the Cabal to Nix tool. This requires rebuilding the Cabal to Nix tool every time changes to this mapping are necessary. The existing infrastructure is package level based. Since the existing infrastructure is package level based, we sequence building and testing of libraries. It leads to mutual package cycles where the test suite of one package depends on the library of a third package, which again depends on the library of the package that's being tested. Thus, often, don't check is required because, like, anytime you're putting things together that get in the way of other things and whatnot, sometimes you have to put don't check in because the one thing breaks the other thing or this thing breaks another thing. So let's talk about why we need another Haskell infrastructure here. At IOHK, we wanted to reduce our burden of having to deal with AppVeyor and Windows CI pipelines. How many of you guys like dealing with Windows CI pipelines? Anybody? Anybody? Yeah, so we were doing this and we were using stack basically in build scripts that were running on Windows on AppVeyor, and AppVeyor builds would time out because the stack stuff would take too long. We had a tool that basically was caching the stack builds to S3, and it was a little bit of a mess. So you can see where we're coming from here. Everything we do in CI is Nix-based, and our build machines, both Linux and Mac OS, are all Nix-capable, but Windows isn't. So we wanted to make cross-compilation initially work with the existing Haskell infrastructure in Nix PKGs. Only after we had issues with the aforementioned drawbacks of the existing infrastructure, too often did we try to solve the issue, but couldn't without fundamentally changing how Haskell packages are built. We have a lot of Haskell software with a large set of package dependencies. Teams are free to use Cabal or Stack in our teams. So we got some developers that really like Cabal, we have some that really like Stack, and believe it or not, we actually have a few that really like doing everything with Nix as well. So I mean, we have a huge variety of the way people want to build their code. So thus we need to be able to build Cabal and Stack projects in CI. and stack projects across multiple LTSs, as different teams may be using different LTSs. So LTS is the long-term releases that are in Hackage and whatnot. So for those of you that aren't familiar with Hackage and how that works. To solve the stack LTS issue, we initially developed a tool called Stack to Nix, which uses Cabal to Nix to turn a stackage snapshot into a package set with Nix PKGs, but it still retained the existing Nix PKG's Haskell builder. This didn't provide to be enough to get cross-compiling working smoothly, and we also kept running into excessive CI turnaround times. Like we'd have some builds that were taking, well, like I mentioned before, AppVeyor builds timing out. Well, our timeout on AppVeyor was 2 hours. So when you have a build that's running 2 hours and timing out, that's a little bit of a pain for developers. So we really wanted to solve this problem. So the Haskell Nix infrastructure. So this was really born out of necessity. If we could have done this without having to write our own thing, we definitely would have, but there were too many things we had to work around, so this is what came out of it. And like I mentioned before, Moritz Engerman, we hired him. He spent about 3 months trying to make all this stuff work without building something. And then he gave us a proposal basically saying this is what it needs to look like for me to get this to work, and he implemented it. We have been using this, although not the latest version with the really cool overlays I'm going to show you soon. We have absolutely been using this since December, and we've been cross-compiling our Windows Haskell builds since March. And it works really well. We haven't had any complaints about the results that we get from the Windows builds. There haven't been any bugs that have arisen that are only in the Nix and not happening on native Windows. So, I mean, we're rather happy with it. So Haskell.nix builds packages at the component level. Thus, if we only need the library of a package, we will only build that one library. And yes, this means we don't necessarily test the library we have built automatically. There are some benefits and some downsides to doing that, but that's a decision that we've made. It helps with our CI times a lot. We still run tests. It's just if you build the thing locally yourself and just get the exe, you're not going to know if the test passed unless you run the test too. By building components, we don't have issues with dependency cycles, as components cannot depend mutually on each other. However, Cabal to Nix does not provide Nix with sufficient information for components. Hence, we wrote a tool called Cabal to Nix, and a tool that translates stackage descriptions, aptly called Stackage to Nix, and one that translates all of Hackage into Nix, Hackage to Nix, as well as a tool to convert stack.yaml project descriptions into Nix, called Stack to Nix, and one to convert configured Cabal projects, Plan to Nix, and all these tools are part of a suite called Nix Tools and are essential to make Haskell.nix work. The Haskell Nix infrastructure is a lot more complex than the existing Haskell infrastructure. So some benefits of using Haskell.nix. It does not rely on a curated package set. Haskell.nix can build almost any package for which either a stackage set or a plan.json Cabal project can be computed. It has component level granularity, does not need don't check to break dependency cycles, and it's faster if given enough concurrency by having component level granularity. Only components are built and dependency can start building once the library components have been built. Also, it doesn't build unnecessary executables if they aren't used, and retains full conditionals from Cabal packages and allows us to configure the OS, architecture, and flags when the package is instantiated in Nix. It does not hardcode library mappings. System libraries are mapped to Nix PKGs through a simple attribute set name. So same for things like licenses, and comes with its own set of compilers and has a much wider range of compilers than those provided by Nix PKGs. It relies on Nix PKGs only for the system packages. So this is a key point here. This is kind of deviating from using the Haskell infrastructure in Nix here. The only thing we're using Nix for are the system libraries, and then we provide everything that we need for building Haskell within Haskell.nix. And cross-compilation was one of our primary motivations for Haskell.nix, and this really makes cross-compilation very trivial, as you'll see below. So some drawbacks of Haskell.nix. It does not have much caching because it's not relying on a curated package set. Caching of artifacts is much harder. Changes to flags will also invalidate whole dependency trees. And it is much more complex and requires Nix to do a lot more work and can mean that evaluations take a bit longer. It has component level granularity and produces many more deviations in the existing infrastructure. So let's take a little sidestep here. There's another project. How many of you are familiar with Snack? Okay, so a little bit about Snack here. So you can kind of look at Nix PKGs is kind of at the package level. Haskell.nix is at the component level, and Snack is really at the module level. So Haskell.nix is kind of somewhere in between the existing Haskell and, infrastructure and how Snack does things. And certainly we'll definitely look into what Snack is providing with us in the future. We did try using Snack. Michael Bishop, also at this conference here, known as Clever on IRC, him and I were trying to get one of our projects building with Snack. And he can tell you the gory details of that, but it came down to, after fixing it to get it to build in less than 3 days, I think we only got it down to about 18 hours. But he can tell you the gory details about that. So simple Haskell.nix example here. Essentially, we need a package set. So we have Nix PKGs. Nix PKGs is defined down here. We use fetch tarball here to get the pin of Nix PKGs we want. And then we put this all in an overlay. And we're grabbing the Haskell Nix tarball here with a SHA. And then we set our Haskell compiler to GHC 865. And then after we do that, and this can really be simplified using, we're using NIV right now. I'm sure Flakes would also make this simplified a whole lot more for passing around the Nix PKG stuff. But after you do that, it's literally packages, Haskell Nix, and then a Cabal project. Give it a path to where your source is. We do have this really cool clean Git stuff here. Clean Git excludes any files that are not in the Git index, if there is one, to prevent unnecessary builds. Haskell.nix also cleans the source on a per component basis, so modifying the source of a test, for example, will not result in the library of the package that needing to be rebuilt. And then we're defining a custom GHC here because we want to use GHC 865 for this project. We also, I didn't put an example in here, but we also have a similar way to do this with basically just replacing Cabal project with stack project, and then it will use stack.yaml instead of the Cabal project stuff. So you have flexibility in that you can build using the stack side, or you can build using the Cabal side. So when we build the package, so you do a Nix build here. It's in a attribute here. So hello.components.exes.hello. And then this is backticks. I probably would have done $parens here, but I didn't write this example. And then /bin hello basically to call it. And then you see some traces here that's using the latest index state. It's using a Git source, and then it's saying that it's not a Git repository, so it's probably a clean checkout, so I'm just going to ignore doing any clean source. Using latest index state a few times, and then it prints out hello world. So that's essentially what it looks like. The same default Nix here can be used to build GTK2HS, which I don't know how many of you have built GTK2HS? Anybody? Was it fun? So that's pretty powerful, that this single thing here is so powerful that it can build a simple hello project, and it can also do GTK2HS using the same exact thing, basically just saying instead of hello, I want to point the source at GTK2HS. The Cabal project file specifies the hackage index state, so that same plan will be chosen every time here. Here's an example of a Cabal project. GTK2HS is an example of a package that is very difficult to build, and it both depends on native libraries and makes use of custom setup scripts. And like I mentioned before, the same default NIX can be used to build GTK2HS. And then the COBOL project file specifies the package index state, so the same plan will be chosen every time. Right there, you see that right there. And Haskell.nix will just respect that, and you're good. How many of you use a Nix shell for working with your Haskell projects? Yeah, lots of people. As well as providing a way to build Haskell packages with Nix, Haskell.nix also provides a shell in which you can use COBOL new build to work on all your packages. It automatically determines what Haskell packages should be available in the shell. And in the case of GTK2HS, it will include all dependencies of Cairo, Geo, glib, etc., but will not include those packages themselves. It includes both the Haskell dependencies and the native dependencies. So right here we have Haskell compiler GHC865 again. We're importing that same default Nix I showed earlier, and we're inheriting the Haskell compiler, and then shells GHC, and then we're calling Nix shell, and you see trace shell for Cairo, glib, it detects all the dependencies, and then you're in a Nix shell where you can build GTK2HS. So working in the Nix shell, when you run COBOL new build or COBOL new REPL inside the shell, it only needs to build the packages that are already included in the project itself. So requested index state, package falling back to older state, resolving dependencies in order the following will be built. There's a list of all your build tools, and that's pretty much it with it. And then we can cross-compile. This is the huge reason we started doing this in the first place. And let me show you how different cross-compiling is. So if you look here, we got the packages, we have the overlays, all that's the same. Oh wait, here's something different. Config, cross system equals pkgs, lib, systems, examples, mingw64. And you can ignore the rest of the file because that's the same default.nix. So now you have Windows binaries built on Nix that you can ship to Windows users, all right here. And that's pretty much my talk. I will take some questions, but if you have anything like really technical or in-depth, you really need to contact Angerman or Hamishmak on IRC because, again, I did not write this. I'm just doing the talk for them. Let me actually see. Nope, it's still compiling. I was going to do a live demo of it, but like I mentioned how it basically brings all its dependencies with it. Well, the next build was building Git and GHC and a number of other things that were needed to get the thing working with the pin I had. So I don't have a live demo for you, sorry. Any questions? In the back.
Hey there, thanks for creating Haskell Nix, I really love it. And I would like to move all my projects where I used stack to Nix to create all the stackage stuff and like produce giant commits with package links, lists. I would like to use Haskell Nix for all the projects now, and I've seen that if I want to have the same workflow like before, so it compiles, builds all the tests too, and only if the tests are successful I get a working result. With Haskell Nix it doesn't seem to be like this. I have this components subset and there it has access and libraries and tests, and it seems like I have to tinker this workflow so that it builds everything and then tests it and then creates the package if the tests work at all, that I have to tinker that myself. Or is there some easy one-liner way that is already included that I didn't see yet?
So I don't have an easy one-liner way because I mean, we're building tons of packages and whatnot across. Most people aren't really running tests locally unless they're working on a specific test, and we're just running everything in CI. But we have some awesome wrappers that you can check in the input-output HK/IOHK Nix repo that helps generate a release Nix file that you can just give it a projects, give it a list of all the projects that you're using with Haskell Nix, and it will generate all the jobs needed in the job set, and then you can also automate creating a required job set that has constituents based on the things that you want to pass. So we basically just offload that to CI, and that's why it wasn't a requirement for building the binaries to be able to pass the tests.
That sounds like a nice pointer. Thank you.
You say you don't check through. How do you get around the dependency problem with the tests? Do you have a different derivation just for the test that gets built at the end?
Yes, that's essentially how it works. You have a different component for every test, and everything basically gets its own attribute in the default.nix, and then again we just basically have a release.nix that says we want to include all tests in our required attribute set.
Quick question on what you judge the overall status of the project is. You say you're already using it successfully at IOHK. Do you know, for example, whether it can build all the packages that are commonly built by the standard Haskell Nix infrastructure, Nix packages? Can it build, let's say, the full entirety of stackage snapshots? And do you foresee or do you plan to eventually or put forward a proposal to replace the generic Haskell builder by Haskell.nix in Nix packages after more testing, for example?
That would be a question you would really have to ask Angerman on IRC, but I don't know if it necessarily fills the same requirements that you'd be looking for in Nix PKGs for a package set because of some of the design decisions that were made with it, but that would definitely be a question that you could talk to Angerman on IRC, and I'm sure he'd be happy to answer it for you.
Yeah, I ran into problems recently or some time ago with the usual Haskell PKG's infrastructure, that it does not really respect the version numbers. Does Haskell.nix respect version numbers or version constraints?
Yes, version numbers, and also you can, we're currently using the stack side rather than the Cabal side, but you can do it with Cabal freeze files as well. It will respect the versions and custom Git repository revs and everything across the project, so it's consistent.
Thanks.
One more.
Do you plan to push it to upstream?
Do I plan to what?
Push it to upstream.
I'm not sure if it could really go in Nix PKGs. I think it's a little too hairy for Nix PKGs right now. Maybe, I mean, this would be a question for Angerman as well, whether it can go into Nix PKGs. But right now I see it more as like something, and maybe, I think some work would need to be done for it to go into upstream. I think more likely if it went into upstream, it would probably be a flake.
Cheers.
Okay, thank you.
So the next talk is going to be about dark and murky past of Nixos. And
All right.
So let's start.
So it's me again. So before we start, I first want to announce a little bit of a contest. The first person to actually package this thing into Nix packages will win this very ugly hard plastic MSN figurine. Actually, it no longer works on MSN because MSN is no longer working, but it does work on Linux. So get cracking. So, and if you're thinking about adding support for this to Hydra, that's even better. So, because you know it actually has LEDs and it can flap its wings and all that. It's really cool. So if you want to be woken up in the middle of the night because your build failed, it's perfect. So I got some more of them. So I'm going to talk about the history of NixOS, and this is not necessarily the real history, so some of the facts might have been changed for a dramatic effect, but who cares? So it's all in the past anyway. So a little bit about me. I actually studied computer science at Utrecht University together with Ilko and Rob, and my master thesis was NixOS. So I created the very first NixOS. So it's because of me that you are here. So it would have happened one way or another anyway, but I just accelerated it. So after that, I drifted away to do other things, mostly first system administration. I used to be on the board of NLURG, formerly known as the Dutch Unix User Group. And then I got more into legal and licensing, so I was on the core team of GPLviolations.org for about 7 years. And now I'm having my own consultancy, focusing on open source license compliance, software provenance, and so on. So things about reproducible builds, where software is coming from, is still very important in my day-to-day job. Because when I actually have to go to court and then show like, okay, this is where this particular software came from, then knowing exactly where it came from, how it was built, is actually very, very important to me. So, about me, so I started using Linux and open source somewhere in 1994, first FreeBSD, and then later we switched at home, we switched to Linux in 1995, Slackware, and that was before Windows 95 was released. So I only started using Windows 95 or 98 when it was already a few years old. So in 1996 I started studying at Utrecht University. So Ilko was actually one of the first other students that I even talked to, so on the first day. So we've known each other for quite a long time. So I already had some experience with Linux, FreeBSD, then we got HPUX and IRIX. I can tell you it's nothing like in Jurassic Park. But and then Solaris a year later. And although I've used Linux exclusively for a very long time, I've always been a bit of a a BSD fanboy, and I have proof. So that's actually Kurt McCusick, so an old Unix guy, super nice guy. If you ever meet him in a conference, just go talk to him. He knows a lot of stuff about the history of Unix, and he's done so much. That's unbelievable. Anyway, there were some frustrations. So some friends actually studied physics, and they got really deep into Debian. And I was using HPUX, IRIX, another Linux, and FreeBSD at home. And then whenever I said, this problem, how should I? And then their default answer would be apt-get install. And that really turned me off. So that's like, come on. So every conversation ended with apt-get install. It's like, okay, bye. And that just does, if they wouldn't have done that, I might have been using Debian, but that was like, okay, this is not for me. If this is your attitude, then this is not for me. All right. So through a friend, I got involved in Rock Linux. I'm not sure if anyone here has ever heard of Rock Linux. One person. It was a long time ago. So, and I especially worked on the UltraSpark port because, admittedly, I was also a bit of a Sun fanboy. But that distribution was a built from source thing, much like Gentoo, but then a little bit before Gentoo, and maybe not as polished as Gentoo. But what attracted me is it was kind of influenced by the FreeBSD port system that I really liked. And in the end, it wasn't a very successful project. Gentoo took their entire market basically overnight. And I just ended up installing Red Hat Linux and later Fedora Core and have stayed with that forever since. So around 2002, I took over the management, or maybe the mismanagement, of a student lab at the university. And I also got very interested in things like portability because of my experience with other operating systems and other architectures as well. So one day, a very big pile of old PCs became available, and we just decided, like, okay, well, these are going to be trashed anyway, so why don't we do anything with it? So I just hold them to the lab, we stacked them up, we installed different operating systems on it, and we started to play with build farm software. So the Samba build farm, Tinderbox, also some build farm software from the University of Amsterdam, and I've forgotten the name. I don't even no longer know. Do you still know what it? Ilko forgot too. And one test case for us was the Stratego XT program transformation tool. So that looked a little bit like that. So the person on the right is actually Martin, who was the number 3 committer to Nix packages. So he hasn't done anything for over a decade, I think, but he can still be found somewhere in the log. So it's a lot of beige, lots of Dell, taking up a lot of space as well. But this is what we did is we played around, and what we found is that the build farm software was suboptimal at best. So some builds would sometimes fail because I did an update of the base system. So some builds, they would run perfectly. Then it's like, okay, there's a security update. I would just install the security update and then the build would fail. And debugging that would just be so incredibly hard. So basically, we took the approach like, okay, well, don't touch it or it will break. Of course, these machines were connected to the internet, so that's not a good idea. But it was a very useful learning experience for us. I wrote a paper about that you can still find. I presented it at the UK UEG Linux conference in 2003. So it was in Edinburgh, it was very nice in summer, just at the start of the Fringe Festival, so I got lucky. So around this time, Ilko had already started working on Nix, and one of the first use cases being release management for, again, Stratego XT. And I have proof for that. So this is from a old conference where it actually says, release management for Stratego XT with Nix. See, I didn't lie. Where he's also talking about stuff that I don't even understand, like, what is it? Software deployment as memory management? I think that's in your thesis, right? So if you really want to know about what this all means, just read his thesis. So, of course, there was already something before Nix. It was called Mac. So that software never saw an official release, but at one point it did have a Wikipedia page. So I think it's probably been deleted a long time ago. And a little known fact, Bram Molenaar from Vim fame, he was also working on a release tool called Aap, which was sponsored by NLnet. There they are again. And one thing is that I connected Bram, whom I happened to know at the time, and Ilko, and they just spent a day talking about, I don't even know what you talked about, probably about ideas about the different systems. You probably know a lot more about that. Or you might have forgotten. Mostly forgotten. It was a long time ago. So, when I was looking for a project for my master thesis, I tried some and failed. And basically, I was looking for something like, okay, well, I really have to finish studying. So, what they actually said is, well, why don't you try to build a complete Linux distribution with Nix? And back then, already some work had been done by Ilko called NixU, which was a quite minimal user mode Linux-based distribution. So it wasn't the kernel, it was basically some user land tools that were working. So there was actually something before NixOS called NixU. I think you can still find it in the repositories. I wouldn't recommend trying it, but it's still there. But my goal was to go all the way and actually install it onto real hardware, just to make sure, like, okay, can we do this? Will this actually work? Because at that time, we didn't know. So I took NixU, I expanded on it, because I'm quite a stubborn person. I tried to build things on my Fedora core, and Ilko was using SUSE. And yeah, well, you know, they say, you know, Linux standard base, well, my ass. Like, no way. There were so many differences between those two distributions that it was just painful. So one of the things was with the C library, I think with the MPTL threading library, that was just a ton of pain. So Fedora took a much different approach to that than SUSE did. And that just caused lots of troubles. So in the end, I convinced Ilko that this was a problem. And then he introduced a statically built environment. And I think that that is still more or less in Nix today, but not in the way we actually made it. So my main contribution there was just to moan a lot, so Ilko would actually attack this problem. And that's usually a very good strategy when dealing with Ilko. You're just bitch. It takes some time, but then it just fixes it like that. So I actually added quite a few of the tools there, and then I added most of them. I did the static builds, I added them to the Subversion repository, and so on. And after that, we just started hacking. So this is a very early engineering note. I still don't know what Ilko was trying to say here, but I think it was a little bit about how the store worked. You really have to improve your handwriting. So after adding enough of the essential tools, we actually got it to work and got it transferred to some real hardware. So both virtual and real. So we had some VMware virtual machines, and we also installed it on a real PC. And we were just happily playing around with it. And then we thought we were toying around, and then all of a sudden we realized, like, okay, well, we forgot to create the bin.sh symlink. But most of the tools worked. So at that time we knew, like, okay, well, a lot of the programs out there actually do not depend on bin.sh being present in the system, and it will just work fine without them. So Linux standards base, you actually don't need it. At least for most programs, you actually don't need it. So at that point, we knew that this would work, and it gave the project a major boost, and that made Ilko very happy, as I can show you here. No worries, this is the worst photo that's in there, but can you see that green stuff there? The SUSE DVDs? Ilko exposed. So when then we installed a new build farm with two main machines called Itchy and Scratchy, and also a whole another pile of machines. So we were definitely into The Simpsons, as you can tell. So and eventually those two machines were completely reinstalled with NixOS very early on. I was just a little bit hesitant, but Ilko just said, yeah, we're just going to install NixOS on it and just use it on those machines. And that worked really well. And I think those machines ran for how long? 4 or 5 years? Quite a long time, doing lots and lots of builds. So it was like this. A little bit tidier, as you can see. So the two main build machines were up there, and the other ones were just all kinds of other machines that we installed with various operating systems. But eventually those were all scrapped, and I think that we only used the two upper machines. So I did some more work on NixOS then. I actually made installation CDs, which I then installed on some of the machines that I showed to you. And I also tried to do some cross-compilation. I had some old Java stations, actually, and with a Spark processor. And what I tried to do is to create a cross-compilation environment with GCC. And that turned out to be incredibly hard. I still don't know why. So these days it's a lot better, but at that point in time it was just impossibly hard to do. I don't know why. Something with the include paths, or that it would have something like the it would try to invoke a previously built compiler for the wrong platform or something, and libraries, and big mess. So after that, I moved away from NixOS, but I still kept contributing to a few packages for a few years. But I don't think that there's much that survives to this day. Maybe a few brackets here and there that you can still find when using git blame. But you know, I still have some of the pictures. It basically says no pictures. So one thing that I can do is actually, so Ilko dug up a old boot session, a movie with an old boot session of NixOS in June 2005. So it's June 2005. So if you want to see that, it's very, very bare bones. But so I think this is actually Ilko typing, but yeah. So this was very, very rough. Not a lot of automation going on at that point. I'm not sure why Ilko was typing so slow. So one thing that you will notice is at this point we didn't actually yet correctly set the path because it said command not found for ls. So we used echo, which was a dirty hack, but it works. So in case you ever wipe your in case you ever wipe your environment, that's actually a good hack. So we didn't actually set the path back then. I think we were just a few months in here at this point. So just so you know, wildcards, they don't work. So now it's so I think this was definitely Ilko typing. We eventually we got there. We just had to find the right derivation. Now, that was very old school NixOS. So I think that's the end. All right, so to wrap up, so technically I started NixOS, but since then it is because of you that it has grown so much. So I actually want to thank you for putting so much work into it and making it a lot better. So thank you. Also, of course, we might have some time for some more embarrassing stories. If anyone wants to hear.
Why did you move away from NixOS?
I got a job, and that didn't involve NixOS. And at that point, I was getting very deeply into the licensing stuff. So I basically didn't have any free time left at all to tinker with things. But I still updated a few packages here and there. Any other questions?
I'm curious about this idea of running the activation script from grub while you're booting. If that was an idea you had from the beginning or something you came up with along the way.
This was 14 years ago. I honestly don't remember. I just needed to get stuff done, so I really don't remember.
Fair enough.
Are you using NixOS again now?
So if you actually saw my talk from yesterday, no, so right now I'm still on Fedora, and that's so some people are trying to convince me to go back to NixOS. So Rob already tried to install it while we were driving here. I just said, well, he said, well, yeah, just give me the laptop, I will install it now. I just said, keep your eyes on the road, it will be a lot better. But so yeah, I should go back into it, but first I have to finish a few other things. First need to get some clients off my back.
Who was the first other person you convinced to install NixOS other than you two?
Oh, it's, actually in our lab there were quite a few people quite eager to install it. So I think so Martin, who was there, was as the number 3 committer, was also very interested, and a few other people in the lab as well. And I'm not sure how it actually spread. Do you still know how it actually spread outside of our lab? Was it through the probably through Haskell, some Haskell people, I think.
I really can't remember. Yeah, there were very early contributors like Ludovic, who started Geeks. I don't know when he showed up, 2007 or so.
There were a few people already using it before, but I think that mostly some of the Haskell people at the university, they started to get into it and probably spread the word.
Yeah, it's all in the Git logs. So I don't
Probably.
remember these things because they're in the logs.
So as soon as they started using it, they started contributing, so then we can find out how it actually went.
I was wondering if you can recall anything from your thesis defense. Like, were there any?
So it was not a PhD thesis, but it was just a master thesis. So I remember basically them saying that it was good enough. So that was a good moment. So no, I actually so there was just a few people there, as like a supervisor, Ilko, and a bunch of others. So no external people. So no, I don't really recall anything. Uh-oh.
Well, first of all, I can mention that the thesis defense was 1 week before the 10-year deadline that you had to reach in the Netherlands to not have to pay back your entire student tuition fee.
Okay, so a little bit of history about that. So when we started, we actually got student loans, and the period to finish it was 10 years, and I finished in 9 years and 51 days. 51 weeks, sorry, 51 weeks, so I had 1 week left.
And the other thing is that you were wearing a sick of it all t-shirt. That was the label.
Yep. But that was just coincidence, because now... That was not an honest... I mean, that was... No. I was wearing that, I think, but that wasn't a conscious decision. It's just a band, you know.
Hey, what did NixOS configuration look like before module system was introduced?
What did it look like? Configuration came later. I like that answer. Yeah, but so basically it was very bare bones, just what you saw. That was it. That is what it was like in the early beginning, just finding the right paths in the store and then just doing some stuff. So it was really just a proof of concept.
Those are some really cool master's and PhD theses that you had over there. Are there any other theses from your department that you remember that are interesting in some way to you personally?
So you actually expected me to have read those theses? So no. So I wasn't into that. I was just glad that I had finished everything. I probably wasn't the right person to have an academic career.
Have you had anything interesting in the lower level, like unikernel space with people? I know HALVM, Galois thing is works with Nix, but have you had anything else in that space?
You will have to repeat that question.
Unikernels.
Unikernels.
That was the question.
So no, the only thing that I actually focused on was just getting Linux to work.
Okay.
So that is all I ever tried.
Did you consider making it with FreeBSD instead?
No.
Not fanboy enough.
So why not? I already had done it for Linux, and I think that with FreeBSD, the whole kernel and user space was much more tightly integrated, so it would have been a lot more difficult. With Linux, the things were much more componentized, so that would actually have been easier.
Sometimes when packaging packages for Nix packages, we have some questions about licensing, what we can include, how we can link, and so on. Would you be willing to help answer those questions?
So we have another week, right? So no, so of course I'm not a lawyer, so I can actually not give legal advice, especially in certain jurisdictions. I'm not allowed to do that, but I do have thoughts about them. That is as far as I can go. But yeah, so licensing and Nix packages, that's something that could be improved. Let me just say that I think that there's a lot of stuff that can be improved there. So if anyone is interested in tackling that problem, I would be more than happy to help. All right. So did anyone manage to package it? No one? Really? So I will be here all afternoon, so if you just have packaged it by then you can just come and pick it up. So if there are no more questions, I'd like to thank you for your time and attention.
Next talk is about to start right now, so please, everyone close to the bar, please quiet down a bit. No one is listening. Hey, the next talk is about to start. Please, everyone here in this area, quiet down. If you want to keep talking, move to the tables over there. No, I'm just saying the next talk is about to start, so...
The microphone stand up here.
No, I didn't, but... Yep. So the next talk is from Nicola Mattia, and he's going to be talking about testing for and deploying to AWS environments.
Thank you. Hi everyone again. So I learned an important life lesson at NixCon this year. If you're going to a conference and aim at giving a talk, it's a good idea, but aim at only one. The consequence is this one's going to be much shorter, so feel free to interrupt, ask questions during the talk, share your experience, and hopefully we'll make it to half an hour. So during most of my career, I had someone dealing with the deployment for me, and I didn't have to care about it at all, until I started this side project called DeckDeckGo, which is a presentation software. And then all of a sudden, I was alone to do my deployments. I had to actually deal with setting up Postgres and everything. And I had to learn about it. So really liking Nix, I tried to push as much of the complexity inside of Nix. And I didn't really want to use Docker-based software for building, for deploying. Thank you very much. And yeah, so this is the story of my journey working or making Nix work for AWS. So first a bit about DeckDeckGo, which is the presentation software that I'm actually using today. So the front end is web components and TypeScript. Web components is a new standard in the W3C for basically creating new HTML tags that have some JavaScript logic in them. I have no idea how it actually works. So this is not my job. My job is the rest, the backend. So the backend was entirely written in Haskell. And for deployment and the build, we used Nix. And actual pushing the artifacts, starting these 3 servers, it's all Terraform. I never quite understood NixOps, so no NixOps there. From AWS, we're using AWS Lambda, which is basically you push some code and it runs somewhere. You don't have to create a machine. You don't have to set anything up. It's just your code is there, and whenever there's a request arriving, it's being run. S3 for storing presentations. SQS, which is a queue service from Amazon that we use for different Lambdas to talk with each other. DynamoDB for... We actually got rid of that, but at the beginning we used it, and the setup in Nix is kind of interesting, so we decided to share it. And RDS, which is the relational database service of Amazon. So, if you want to check out DeckDeckGo, it's fully open source, it's on GitHub, deckgo/DeckDeckGo. It's a whole bunch of JavaScript, so that might be a bit scary, but there's some Haskell and some Nix. All the code I'm going to show during the presentation can be found in this directory here. So feel free to have a look. Now, as I said, I didn't have much time to prepare this talk, so I'm missing one slide, which is the last one. And it's actually quite convenient, because I can show you how DeckDeckGo works. You have a set of templates. You can select one. Going to have a last thank you. No. And there you go. So, the first part is going to be the actual Lambda part. So I have this Haskell code, and this Haskell code needs to run somewhere in AWS. And for this, Lambda is great, because Lambda is really just this abstraction. You don't have to start the server, you don't have to stop it. The problem is that when you build stuff in Nix, most of the time you need a Nix store. Or if you use NixOS, it's very simple, just copy the closures, activate, and that's it. On Lambda, you have very limited size. I think what you push to AWS can only be 50 megabytes, so you can't fit an entire Nix store most of the time. You can't have the GHC closure with it. So the answer here is to use fully static Haskell executables, where there's no dynamic linking at all. You don't even have an interpreter bundled in your executable. And there's one guy here, Niklas, where is he? Over there. Big applaud for him, who made amazing work on getting this to work. It's kind of a very nice project because it's Nix, and yet it allows projects to live outside of the Nix store. So you have these standalone artifacts. And it's using CacheX, so it's really a lot of the community coming together on this one. There's a funding page somewhere, you can find it on the GitHub project, nh2/static Haskell Nix, and so feel free to chip in there. Now, so we build these Haskell executables, then we just put them in a zip file, and the zip file is sent to AWS and just works. The actual upload is done with Terraform. So how does this static Haskell Nix work in practice? Most of you do Haskell here, and this is using the legacy Haskell platform, not the new Haskell. And I just want to show you how it works, or how you can make your any executable static, pretty much any. So this static Haskell Nix thing is basically just where the Niklas's project is, and there's a survey directory, which you can just import, passing it your normal packages. In this case, my normal packages are just Nix packages with some overlays, adding DECDEGO's custom packages. And then this is crazy, because line 16, you can see, just do survey.packages with static Haskell binaries, .haskell packages, and there you go. You have your Haskell packages that actually compile to static, fully static executables. This is beautiful. And then when you create your Lambda, you just copy an executable, for instance this one. There are a few bugs, right? So might break at times. Just copy the executable, zip it up, and that's it. Any questions on this? Great. And then the next question is, okay, we have some stuff that's being built with Nix, but how do we teach Terraform to reuse that? And on the left, there's a weird thing. So this function handler path equals built-in seek something, and then the function.zip. The idea is that Terraform has this data external resource, or it's not a resource, it's actual data, where you can tell it, hey, Terraform, just run this command, and you can expect this command to output JSON. And then you can use this JSON in Terraform as well. So line 3 to 9, this part here, are just the Lambda description. And the file name is the zip file that's expected by AWS. And here, this file name refers to data external build function usual path, which is defined line 12 to 19. And most of the time in Terraform, you have to say, oh, Terraform, please recreate this resource if the file hash has changed, for instance, or if the time of the day is later than something like that. So you have weird ways of making sure that Terraform notices when your code changes. In Nix, it's not a problem, because the entire file name is going to change whenever you change code. So how this works is that we do a Nix eval. It's basically going to evaluate something and tell Nix to actually print the output as JSON. So this is very, very cool, very convenient, because you don't have to have any other commands that you run. Just call Nix, output JSON, and that's it. The weird part, which is here, so this is just to make sure that your function is actually being built. It's like a deep seek, because this is just an eval, right? Nix will try not to do any build, and this one will give you a path back, but the path might not exist yet. So you just do a bit of a dirty trick here to make sure, it's basically import from derivation to make sure that the thing exists. Now I'm going to go into the AWS services themselves. So Lambda for running the code, and now we'll talk about S3 and the rest. So the talk is deploying to AWS, but also testing for AWS. So I think this is the interesting part, because when you ship some code, you deploy, you don't always want to run a staging environment where you run your integration tests. So what we're going to do here is just, for each and every AWS service, we're going to try and find either an open source alternative or some jars provided by AWS, some form that we can execute the services locally inside our Nix build. And then we just redirect the URLs during the tests to the local servers, and we'll repeat for the next service. So we're going to do this for a few services. First one is S3. So you probably all came across Min.io. Who's seen it before? Okay, so Min.io is an open source clone of AWS S3. It has its own protocol, but it also speaks S3 protocol. And it's a nice project. Works for my use case, which is testing. I heard people say that it was working great if you use it as a full replacement in production. I heard some people say that it wasn't that great if you used it as a full replacement in production. So it depends a lot. But for testing, it works just fine. And how this looks is very simple. You add Min.io as an input to your derivation. You set some domain environment variables because it requires them. And you start the server. You say localhost 9,000 for the port. Give it a temporary directory where you can actually store its artifacts. And that's it. It's running, and you run your integration tests. The last thing you need to do is actually tell your code to use localhost as opposed to canonical AWS URL. In the case of Haskell, I'm using Amazonka. And you can give your own HTTP manager to Amazonka and just tell it, hey, listen, if you see S3 Amazon AWS.com, well, just redirect to the local one, disable HTTPS, and that works. Make sure to only use that during your tests and not in production, of course. Next one. Oh, questions about S3? All right. Next one is the simple queue service. So this is just for sending messages between Lambdas using AWS. It's an AWS project, works fine on their server, but for this one, they don't provide artifacts, or they don't provide a way of running it locally unless you use Docker. But there is an alternative one, which is ElasticMQ. Very much like Min.io, it's an open source clone, but it speaks the SQS protocol. So what we do is that we just grab the artifacts that they release on GitHub. It's a jar, we just Java it, and it runs. So I feel a bit dirty inside for starting Java on my laptop, but as long as I don't have to start Docker, right? Wash, rinse, repeat, just as we did for S3. Replace the host, replace the port, disable SSL, and we're good to go. DynamoDB, who's here has heard of it? Yeah. For the others, it's basically like Redis. It's a very simple table format database. And on this one, AWS is actually pretty cool because they do provide ways of running it locally. You can download the jar, which you can just start on your laptop. By the way, all these services, even though they use network, they never require anything like sudo or... So that means that everything can just run in derivation. It's actually very nice to have your tests running, fully sandboxed. If someone else in your company has run the test before, they're going to be cached in your shared cache if you have one. You don't even have to run the test yourself. So here you just grab any of those jar bowls, you unpack it in your derivation, and you just say, okay, Java start, you have some options to set, the port, and after that, you run your integration tests, and you don't forget to tell Amazonka to use your local version of DynamoDB. Questions for this one? Great. Now what about Postgres? So Postgres is actually interesting because the exact same Postgres, or mostly the same Postgres, is going to be running on AWS. And for many, many years in my life, I thought, okay, I have tests that run Postgres, so that means I need to install Postgres on my laptop. I need to install it through Ubuntu or a service in NixOS. But you really don't have to do that. And this was a eureka moment for me. Postgres can use any kind of directory, and it runs as a background process if you want to, but it doesn't have to be a system-wide background process. That means that you can even start Postgres in your Nix shell, or you can start Postgres inside a derivation and just kill it at the end, and you don't have to tamper with your system-wide Postgres. So you just tell Postgres, hey, just initialize the database in PG data. This is just a name I give it. You have some configuration to set, but that's about it. Then you tell it, all right, start, and from there on, you have Postgres started. You just make sure that before you do anything else, you give it enough time. Then you create the databases you're going to need for your tests, and that's it. Run your tests. At the end, you say, all right, immediate stop, and no traces left of Postgres in your system. Everything clear here? The really cool part about that is that so all these services are provided through Nix, and they can be started and stopped at will. All these services so far have used temporary directories, so they're not going to write anywhere else than in your temporary directory folder. So you can go one step further with this, is say, well, I'm going to have a shell wrapper that's actually going to start my services whenever I develop locally. So if I don't want to do a full Nix build for my thing, maybe I'm using GHCI for development, but I still need the services to be there. So this is something I find very, very, very valuable, is to have those small shell wrappers that gets initiated in a shell hook, and it just creates a few functions that you can call from your shell, from your command line. So here I have one. Oh, is it big enough? Say something. Sorry? So this one is for loading Postgres, very simple. And this is where the heavy lifting happens. This function is store services in terms of UX. If you have coworkers that don't really use Nix or don't know about Nix, they don't want to set anything up, you just tell them, well, enter the Nix shell, and when you want to start your services or when you want to run your tests, just call start services. It's going to load Postgres. It's going to start SQS as well. It's going to start S3. And then anything that happens after that is going to have access to all these services. And when they're done, they just call stop services. And everyone's going to thank you for this, because most companies now still do, okay, you want to run the tests, oh, you need Postgres, just do sudo apt install Postgres, and with this, no need for that. People don't even need to know that Postgres exists. You might want to add a few things like a few REPLs that set environment variables. Here, we actually need our tests to use some JavaScript built stuff, so set an environment variable where there's some built JavaScript that was built by Nix. If you forget how you actually did the packaging, you don't have to worry about it. I'm using this once a month. We started working in April, I think. One day I packaged it, and now I don't have to worry about it anymore. I actually forgot how it works. And that's it. Thank you for listening. Do you have any questions or experience reports that you want to share?
So, are you aware of NixOS testing suite when it spawns QEMU machine, and you can use actually Nix description language to start the services inside? And if yes, why didn't you use it?
So first of all, I'm not using NixOS in productions, right? So for a NixOS test, means I would have to create a new NixOS module with my code, and then ship that and do a full Nix build. The other problem is that NixOS tests only run on Linux, as far as I know. They could run on Darwin, for instance, but no. So I'm using Linux, but the friend I'm working with on this one uses Darwin, so it wasn't really an option. And also, it doesn't allow you to do the local development, right? If I use GHCI to test my code, I also have unit tests that run against Postgres. So in that case, that would mean, okay, I'm in GHCI, I make a change, then I close GHCI, I do Nix build, then it has to build everything, actually rebuild from scratch the whole library, the Haskell library, and then start the tests. It would take probably a minute for everything to happen. Whereas if I just start Postgres in the background or anything like that, I just do :R, reload GHCI, main, runs the test, and I'm good. Iteration cycle is about 5 seconds. Yeah.
Did you look at TerraTest?
At?
TerraTest.
TerraTest, no, what is it?
It's a framework wrapped around Terraform to do integration testing. So it spins up components, runs a test cycle, and destroys those components. It's a little bit like InSpec and server spec, but baked with support for Terraform.
Very nice. So I'm guessing this is also something that takes some time to run, right? But this is, I didn't know about this, and this is great. Boss,
It has
taking notes?
some overlap.
Thank you very much.
I also wanted to make another tooling suggestion, which is TerraNix. I don't know if the TerraNix author is here today, but it's a really cool way to write Terraform, the syntax, in Nix instead, and it does away with all the horrors you have to go through when you realize that the Terraform language itself can't do all kinds of stuff. You can write it in Nix instead, and I find it very convenient. So that might also be something that's useful.
Yeah, although if the goal is really to hide Nix from your coworkers so they don't hate you, this is a bad move.
I have a question. Do developers use these services started from Nix shell for local development, or only for test running?
You mean these?
Yes.
Yeah, so in this project, I'm the only Haskell developer, so I'm the only one using the REPL things, for instance. But whenever I work at a company, basically whenever I work, I write these, and people like using them because it makes their life much, much simpler.
Okay, I have a question then. What do you do with front end? Is it started like this, or do developers don't run the front end locally?
I don't do front end. I let them deal with their mess.
So
no, I don't know. They use
everything except front end, right?
Yeah, exactly. So they use Webpack and whatever they use. So I have no idea how it works. So I'm not even attempting at helping at all. Sorry. Oh no, that's not true. No, I've done it before. For a different company, but it was very tricky to get right because most of the time their editors are very tightly integrated with the build system, and so it just breaks everything for their editors, which is a common theme in many languages actually. All right, thank you very much for listening. Don't hesitate to find me at the end. Oh, no, it was a clap. Great. Bye.
The next talk is going to start in 10 minutes. 2 minutes to the next talk. So next up is Prof Patch to talk to us about Lori, what it is and how you can use it. Get ready guys, the talk is starting now. Just press the button.
Okay. Nice. Hi, I'm Prof Butch. NixShell is a superpower. Who here agrees with me? Okay, I see. Why is NixShell a superpower? Right? So I have a few points, there's probably more, but first off, you can define ad hoc environment for your project. It sets all the environment variables you want, just works for everything that's in Nix packages essentially, which is by now probably everything, right? You can check the file into the Nix version, into the Git version control, and every single developer gets the same environment. Wonderful, no problem with works on my machine, or at least less problems now. You get as fine-grained dependencies as you want or need, but you still get everything cached from the Hydra. Also beautiful. And basically this supersedes everything from pipenv over virtual envs over whatever your language uses. Just has one environment and everything works. And I mean, you can even use it on CI, and you have the same environment on CI. You can get around all that Travis stuff and just use NixShell on CI and it works. So NixShell is a superpower. However, it doesn't make you invincible, right? Oh, and it was never intended to be a superpower, actually. Because the first idea was, probably Echo thought, I want to debug what I'm actually writing here. So I want to debug the builder, essentially. So what NixShell actually does is just gives you the environment of the derivation you're working with right now. Exactly the same thing with all the compilers set, with all the strange environment variables you want. But people soon realized that it's actually a lot better than just being a debugging tool, because it's very powerful. So everybody uses it right now. And of course, it's still a superpower, but it also doesn't make you invincible. There's quite a few problems with NixShell right now. The projects are getting bigger and bigger. So once you start having a few developers working on that and a few dependencies and maybe even multiple Nix packages clones, your instantiation time is going to go up. And your Nix shells are going to use more and more time to open. So we had cases where it took like 1.5 minutes on Linux, and then even up to 20 minutes on macOS, right? On business macOS MacBooks, who have these file checkers in the background who check every file access. So now Nix instantiation takes 20 minutes. You garbage collect your Nix store, suddenly all your project dependencies are gone, you have to re-download everything again. Time for the waiting game. Something changed, you have to exit NixShell, you have to enter NixShell again. You have to wait for rebuilds, and so on. And of course, you can only use this in your shell. So good luck with setting up Emacs with that. There's a way to do that, but I'm going to talk about it later. So we thought about those problems, and we came up with the following. This is Laurie. Laurie solves all these problems for you. So my thesis, or the thesis of this talk is, if NixShell is, or Nix is Batman, then Laurie is like Robin, right? The small helper, superhero. And I'm aware, of course, that Batman doesn't actually have any superpowers because Batman uses cool technology like Nix and NixShell and Laurie. Okay, before I come to the main act of this talk, a short history of how this came to pass. Because Graham had already started experimenting with improving NixShell, I think over a year ago, maybe 2 years ago. So I have ideas. And then a company came along called Target. Yeah, we want to improve that. We have problems with this. And Graham said, okay, we are Tweak, we can do that for you. Just say what you want and we can do it. Okay. At least that's how I think this went. It was probably a bit different from that, but yeah. Okay, we know history. It's time to meet the villains because we already have the superheroes. So Robin was thinking he wants to develop on his project, right? He CDs into his project. He opens a NixShell, and nothing happens. A few minutes later, oh, okay. Why did it take so long? Yesterday, just like a few hours ago, maybe yesterday, I closed my NixShell, I closed my desktop, I went home, came back. Now I want to start working. Like maybe I have a few ideas, and boom, have to wait for a few minutes. Yeah. Why does it take this? And of course, I think you probably know why, but Robin was asking this to himself. Batman didn't seem to care very much because it was a good time to get a coffee or two, right? But Robin is young and he wants to do something, and so he has a problem with this. So he decided to find out why this happens. So he decided to look at the source code. This is NixShell, like this is the actual implementation of NixShell. I shortened it down a bit, like originally this was a Perl script, and this got ported to C++ by Schlevi, and now it's just in the nixbuild.cc file. You can just look at it. It's not that simple, but it's also not terribly hard, and it's all in one file, so you can follow the code flow. But in essence, I think I pretty much shortened this down to a few lines. So the first step is you get your shell.nix, or Nix gets the shell.nix, and it calls this function derivation from path, which returns a DRV file. So this instantiates the Nix expression, and then it gives you the DRV file. Then it takes the dependencies of the DRV file, because remember we're opening a shell here, so we don't want the derivation, we want the dependencies, and builds all of these. Then it gets the environment from the DRV file and sets it for the process it's going to call. The process is going to be a bash with some RC file, and it's execs into bash. And then basically Nix, the Nix thing is dead, and bash runs with the environment of your shell.nix. Okay, thought Robin. So why is this taking so long? The first 2 lines. Because every time you want to exec into the bash, it's going to have to open the shell.nix, evaluate everything, every dependency in Nix. That's basically a functional language, so, and maybe not that optimized, so it takes a while, and then it can exec into bash. How could you solve that? Just use the last build you did yesterday, right? So Laurie solved this by keeping around the last build you did, and when you enter your project, you immediately get the environment of the last build you were in. And then it starts in the background giving you the new environment if something changed. And most of the time, to be honest, nothing really changes. Second problem. Robin Robin wants to run his command something. And he sees this message. Oh, okay, of course Robin's a Nix developer, so he immediately types this line. And of course the Nix store has grown by a few hundred gigabytes in the meantime. All right, there was this handy dandy command that you can give to the garbage collect. It's called max free, 30 gigabytes. Should be enough, right? Nice, I have space again. Let's open Nix shell. Nothing happens. Why is there no GC root for my Nix shell? This can't be this hard. So very easy, Lori just creates a GC root for your project. And if you get a new version of your project, it just overwrites the old one, so it is available for GC again. So you always have it in your, it never gets garbage collected when you don't want it to be garbage collected. Third problem. Oh, my notes are a bit too big, sorry. Okay. You're in your Nix shell. Robin is in his Nix shell. He wants some other person comes and says, oh, check out my new PR. It has a few changes. Okay, so git checkout, some PR. Now run the project. New tool is missing. I didn't know about new tool. Probably the other developer added it in the meantime, right? So now Robin leaves the Nix shell. Robin enters the Nix shell. Why they didn't start evaluating the new state of the project when he switched the git commit? So the idea here is that once you check out something and basically the files, the dependencies that you need to open your Nix shell change, you immediately want it to run in the background and start building, preferably on your company's server, the new version of all the tools you need. So that once you try to run it, it's if possible, already finished, and you don't have to manually exit Nix shell and manually enter Nix shell again. What up? And it should also provide you a way to integrate this into your environment. So it should give you a steady stream of messages that say, oh, this changed, now I'm starting instantiation. Okay, I'm done instantiating, now I'm starting the build. And so you immediately see that when it's done, you can say, okay, switch to the new environment, and now I can try this again. Okay, now we have something that works for our shell, but how can we actually integrate that in our editor? For example, you might want some things like I don't know, these squiggly lines under your code when you miss something. And you actually want those tools to come from your environment, right? And Robin kind of starts dreaming about this world where he can just switch buffers between projects and immediately have the new environment in his project without the editor blocking for another 1.5 minutes every time he switches between projects. So there's this beautiful tool called direnv, which is written by the wonderful Zimba TM. He's here somewhere, I guess. Which basically takes care of that for you. And it has integration for all different editors, for different shells, whatever. And Lori just provides you an integration into direnv. So you add like one line of code to the direnv, the env, and it just starts working with the normal Lori environment. It never blocks anything because it uses the last working version when you switch environments. And now that all these problems are solved, Robin is pretty satisfied and decides to tell Batman about it. Okay. Yeah, this is a project. It's on GitHub. We have good first issues for you to solve. Please try it out. It's very easy to install. It's about one line of code, nixenv -if, some path, some link to a rolling release branch. You will have access to the tool. We have a handy dandy tutorial for you to step by step set it up in the repo. Yeah, there's some good first issues. So if you want to program some Rust for the Nix ecosystem, and Hacktoberfest is still going on, right? So, and feel free to join the Freenode channel. We have a few things planned for the next few weeks and months. First up are services. So now that the base integration is already working, we want to think further of like how can you get Nix to integrate into your projects better. For example, if you have some web project, you usually need a database server and you need some, I don't know, microservices running. And Nix can provide you the environment, but Nix can't start the services for you. So right now you have to write bash scripts and then you have to care about the lifetime cycle of these services. So the idea is that that Lori should have a subcommand which just takes care of that for you. And we're still thinking about how to design that. We want to add some linters to your Nix project. So a common problem is you see this line here, which is basically always wrong, because what that does is it copies the whole directory you're referencing into the store before it does anything. And if that directory is your current source directory with all the debug outputs in it, then it's going to change every time basically you run Nix or Nix shell. So it will have to copy everything, and so you have to filter those. And you want Lori to be able to warn you if you do something stupid like that, so that new programmers don't run into this anymore. And of course that entails that we want to be able to write these source filters and make them easily debuggable as well. And finally we want to upstream some of our changes into Nix proper, because it's important that other people can use these tools as well. Right now we're just hacking around Nix and Nix build -vv and parsing the output, like probably other people are doing for their tools, but it would be really nice if Nix can tell you what it's doing in the background while it's evaluating or while it's building something. Cool. So in conclusion, what Lori gives you. It gives you instant environments for your projects. Last state, you left the project, you enter again and it's there again. It auto sets up GC rules for your projects. You never lose it when you GC. It watches dependencies in the background, so basically Nix files, Nix packages, check out JSON files, everything. And auto builds in the background, and it has nice editor support without blocking the editor, even Emacs. Yeah. Thanks. Any questions or input, whatever? Maybe we can do a show of hands. Who here uses Lori already? Okay, that's potential.
I was wondering, is it necessary to install Lori first, or can I ship it with the shell.nix file and just have people use Nix shell and under the hood kind of use this Lori feature, like a bootstrapping of the tool?
I think you can, actually. I haven't thought about this, but it should be possible. I mean, you have the setup problem, where the bootstrapping problem, but once you have your Lori environment, you're gonna have Lori in the project, right? So the next time you CD into the project, when you have DRM set up, you will have Lori in the environment again and can use that. Yeah.
It's not a question, but like, so the way I use it, I don't really change the env-rc of the project to use Nix. I prefer to change the my dir env-rc for my system to use Lori, and that way I'm not forcing anyone to use it, and it's just like my decision. So.
Oh, so there's a system-wide env-rc file.
Yeah.
Okay.
So instead of like forcing it on all the developers who use the project, I let them make the choice. I just leave my project NVRC with use Nix, and I only change my own dear NVRC file to use Lori.
Okay.
That's it. I do have a question. So, by the way, thanks for Lori. It's a great like product, daemon, tool, whatever. I was wondering whether there is a way to like tell while it's building in the background so that I can, I know, like make my prompt change while it's still building so that I know. Because right now it's like press enter, 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 and I wait.
It's actually something we want to do next, to have a stream of information you can integrate into your window manager or your Emacs or whatever.
Okay, so coming up.
So just printing like line-based JSON output of what is going on at the moment, and you can filter that and integrate it into your system if you want to.
Sweet, cool, thanks.
It's not like a question, but maybe a proposal to push Lori as a core Nix. Yeah, I think that you can't merge it to Nix code repo, but you may provide Lori as a Nix plugin, so we can distribute Nix with plugins, and Lori is one of the plugins, and it will be able to do the things.
So I personally had very bad experiences with Nix plugins because you have the very, very bad bootstrapping problem there. Like when you have a Nix without a plugin and then getting the plugin in, but I don't see the problem why you wouldn't install it like a normal program and use it.
I have a related comment. I was thinking about something similar a year ago, and I actually started implementing it as a Nix plugin. But it turns out that Nix plugins cannot register comments additional, like they are meant to, but this code doesn't work. And I have a PR open since December that fixes this. So if someone can help me get it merged into Nix, that would be great. And then we would have a lot of amazing Nix plugins with comments and stuff. Thanks.
When you switch branches and Lori adapts the environment to the possibly new required packages, how do you keep track of what GC routes you still need? Or do you have some sort of UI of listing those and maybe saying, okay, this branch has been merged, so I won't ever be needing this anymore? And if so, do you use the branch name somewhere so that you can recognize that it's old?
So right now it only, basically it has one place for each repository and it overrides the GC root every time you switch the environment. But we could add something. I mean, this is all experimenting, right? We're just trying to experiment with what we got and see what's nice for the users. So if you have any ideas of how to do that, because like GC root management is a really hard problem that we really should focus on solving. That the user can say which ones, which dependencies they want to keep and which not.
If I can make a suggestion, I think it would be great if you sort of keep a log where you say why a GC root exists, so that you just say, because it's a hash, so pretty unique, and then have a text file somewhere saying this log was, this GC root was initiated because of this command at this date. So then you have some context by which you can remember if it's still needed or not.
So if anybody here wants to write a separate tool which manages GC root with like an interface that we can use, then we just add support for that. Because that's something that's completely orthogonal, I think, and that's required by a lot of projects that use Nix. That would be a great small project to do, or yeah.
Does it have something like update all environments that it knows about?
Sorry, which kind of environments?
Like you said that it already tracks GC routes for all of those projects that you're working on. Does it have something like update all? Update all of them, like rebuild all
Update
of them
all
when
of
I do
them.
Nix channel update.
No, we don't have something like that currently, but it shouldn't be hard to add if you need it, right?
But does it track the directories themselves, not just the GC roots?
So we have a daemon part of Lowry,
Uh-huh.
which basically manages all the watchers, and which has a socket where other Lorry tools communicate with it. And basically, when Lorry is running, it will track which projects it's watching at the moment. But
Okay,
there's no
so you don't know
global
that.
stateful file somewhere which has a state of which projects there exist. Like no database. Huh?
When you cd into the project, it would check that, right?
There's in the cache directory, there's basically a hash of the path of the project.
Is it possible to run it without the daemon part? Is it possible to run Lorry without the daemon part?
There's a command called lorry watch -- once, which only runs it once. And it still has the if you use it with DRAM, it still has the property that it will always switch to the last time you ran this command.
Thank you.
Thank you.
We are starting in 1 minute. Fifteen seconds.
Four, three, two, one. I actually didn't count. Hi. Right, I'm going to be doing a little bit of dual microphoning. I've noticed kind of throughout the course of the conference that very few people are doing demos. So I'm a little bit afraid that the demo gods might actually be striking down all of their vengeance upon me today, because I have 4. So we'll see how that goes. Right. Hello, everyone. My name is Vincent. I think I know probably half the people in the room already. Test 1, 2, 3. Okay. It's a good start. Right, let's do it this way. My name's Vincent. I think I know about half of the people in this room. Tasgen is my username. That's probably the name by which people know me better than my real name. So yeah, it's the same username on GitHub, Twitter, IRC, whatever, so that's how you can reach out to me. Cool, so I'm here to talk to you about Nixery, my fresh and healthy way of building container images. And to kind of kick that off, I want to give you a little bit of an overview over what the container ecosystem looks like at the moment on a very high level. So, quick show of hands, who has never used Docker or anything like it? Okay, very few people, cool. I'm not going to go into what containers are and so on, but I'll say a little bit about how the tooling works, because that's kind of all the background that you're going to need. So Docker has a concept of images that are basically like root file systems of a distribution that are made up of a bunch of different tarballs called layers that are distributed over a registry protocol. The details of how this works under the hood don't really matter, but the important thing is that there are different layers that get merged together. So if you have a sequential list of tarballs that contain non-overlapping paths, then they will be squashed into one file system. If you have overlapping paths, then the ones from the latter ones in the order of the image manifest appearance are the ones that take precedence. So this syntax over here is what's called a Docker file. This is the default method of building Docker images. You specify the base image that you have at the top, which in this case is Ubuntu, and then you run individual commands, and there's a bunch of additional instructions such as env, which sets environment variables and so on. What happens when you execute this is that Docker goes and it takes every single instruction in this Docker file and it executes it, and it takes the resulting diff of file systems and turns it into a layer. What this means is that this is inherently extremely stateful, because there is no care taken to make sure that things like timestamps on files are in any way normalized. So things that we deal with in Nix on a very fundamental level just kind of don't exist conceptually in this world. So I actually took this particular Docker file and I ran it twice earlier today. And here are the hashes resulting from the 2 image builds. As you can see, they have nothing to do with each other at all. This was kind of my reaction. And a while back, I already started thinking about whether or not there might be a better way to do this. Those of you who talked to me at the NixCon in 2018 probably heard my ideas about a Kubernetes controller for Nix. I will get to that in a second. But also there have been other people working on very similar things for a while. So there was an initial attempt, actually not an attempt, it works, to build a Docker image via Nix called just build image. That's in docker tools.build image. And what that does, the way I understand it, is it spins up a QEMU, installs the things that you want in it, and then takes a snapshot of that file system plus some extra information. That was the first idea for building Docker images in Nix, and it actually worked reasonably well. And then Graham C., is he here? Somewhere he is. Maybe not in this room right now. Anyways, he wrote a thing called build layered image that I will be referencing a couple of times throughout the talk, which takes a more pure Nix approach to the construction of the layers. So instead of spinning up virtual machines and snapshotting their disk, it actually uses Nix to construct the tarballs themselves. Right. So about a year and a half ago, I had this idea for what would the world look like if we didn't actually have to build these container images explicitly, and we just have some sort of content specification that tells us what we want in an image, and the image is built based on that. So here's a mock-up of something that I kind of prototyped in the beginning, where we added an extra resource to the Kubernetes API. That's something that is supported in Kubernetes. You can see that up here. And then we had this simple YAML specification where each of the keys referred to a top-level entry in Nix packages, and you kind of submitted this into your cluster, and then a daemon kind of ran in the back of the cluster, built an image out of this, pushed it into your registry, and did this whole normal stateful kind of dance, but abstracted away for the user by just creating an image with this name. After building this, an interesting thing happened. So I tried to demo this to people. And it turns out that when you're demoing this, there's a lot of moving parts in it. You need to write a YAML file, you need to submit the YAML file to a Kubernetes cluster, then a thing needs to run in the background and build the image and push it into a registry, and then Kubernetes launches pods that pull the image from there. So you've got I don't know, 6, 7 things that can go wrong, and they all take a little bit of time. So it's the kind of demo where you try to show it to someone, you make a few typos, and they're kind of half falling asleep, and you're like, but trust me, this is a valuable concept that I'm trying to get across. So I actually invented on the fly at some point this idea of a demo mode for the controller. So the idea here was that instead of having a specification pre-hoc of what goes into the image, we just use the components of the image to describe what should go into it. So there are kind of 2 main parts here. There's the host name, which is just the address at which Docker should look up the image that you're downloading. Then we've got a section that describes the packages, and the first ones in here are so-called meta packages, which is kind of a shorthand for sets of packages. So shell, for example, gives you bash interactive, IANA, etc, and all these kinds of things that you probably want if you want a shell environment. And then you can specify path-separated other packages that should go into this image. So I built this demo mode, and then I realized that that's actually a much better idea than the first one I had. And then I kind of scrapped the actual controller, and was just like, this is the way forward. Right. Before we talk about this slide, I'm going to start doing my first little demo just to show you what this thing actually looks like in practice. Okay, microphone number 2. So here's the public instance of Nixery. It's available at nixery.dev, and this is kind of like a public service that you can go and play with. So just to remember, I can. You don't actually need to read this. I'm just trying to show the logo as often as I can because I spent countless hours designing this, as you can see. So let's do a little demo of this. Here's the standard Docker CLI. What this command says, is that readable enough? Nope, okay. Excellent. What this says is we're going to run a container, we're going to attach a TTY interactively, we're going to remove the container after we're done, and then we will pull the image from nixery.dev, and we want an image containing shell. So as per the previous slide, this is going to give us an image that just contains a basic bash environment in a second. So, and I need to actually tell it what to run. So here we go. Here's a bash. It's got core utils and all sorts of things installed, but no additional programs. If I try to run htop, which I didn't specify in the image, it's not going to be included. So what I can do is I can exit out of this, and I can edit it to include additional programs. Again, these are just referencing keys in Nix packages, and then an image is built on the fly and kind of sent to me. And now I have a shell in which I can actually run htop. So that's the basic mode of operation. In this public instance that's running at nixry.dev, I track whichever is the latest NixOS channel, and I do updates for this roughly once or twice a week. But it turns out that what's actually a much more interesting use case than just having a thing that can give you these arbitrary images ad hoc is the ability to add your own private services into it and see how this can be useful for CI in organizations. So there's something I have to show. I personally am a monorepo person, and here is the default.nix of my personal infrastructure repository. It contains stuff like my blog and so on. And this is mostly standard Nix stuff, so there's nothing like super interesting to show here. I import Nix packages from a pin commit, and then I have an overlay that overlays my standard packages on top of it. If you want to know how this works in detail and have discussions about pinning channels and so on, we can do that after the talk, because it's a slightly different thing. Anyways, in here I have a thing that I built, which is the NixCon demo, using N. Matthias, where is he? Also somewhere. Excellent Nashk, which builds Rust based on log file specifications. Huge fan of that. And I wrote a tiny, that's the wrong one. I wrote a tiny demo, which just looks like this. It can either run as a web server showing me this nice message. I hope for the Czech people here that I spelled that correctly, trusting the internet, or run with the CLI argument. It doesn't really matter what this program does. I just want to show you that there's an actual thing going on here. So I'm importing that into my Nix package set, and then I have it available in my overlay of packages. So down here I have a shell in which drenv has just, thanks to Zimba, has just loaded some environment variables for me, and one of them is the one called Nixry packages path. So I support multiple different sources for importing package sets into Nixry. And one of them is using Git repositories, and one of them is using local file paths. In this case, I'm just using the file path of the checkout of my repository. So I'm telling Nixry that the package set from which I want you to build images is the one I have at this place on my disk. So what I can do now is I can go and spin up a Nixry in here, which looks like that. And then over here on the other side, I can do the same thing I was doing before with my shell, but instead of pulling from nixry.dev, I'm pulling from localhost. So this is the local instance I have running. So this one wasn't particularly interesting because it was cached already, I think. But yeah, I just want to show that there is nothing in here right now. So there's no program called NixCon demo. Now I'm going to remove that image just to prove to you that I'm not going to try and hit any caches here. I don't actually, it would help if I could spell. I don't have it even. So then we can go and run this command again and add this one to the image. Yeah. Here we go. Could not find Nix package. Thanks. Here we go. Okay, so what was supposed to happen is that I pull an image down now, and it contains the binary that I've added here. Quick show of hands, how much time should I spend working on getting that demo up and running versus not? Okay, I'll give it 20 seconds. So. That looks correct to me. And then here at the top somewhere. Yep. Okay. It's just called NixCon. Here we go. Right, and now I have my NixCon demo thing in here, built from the package set, overlaid into my local configuration. Cool. So that works, and it actually turns into kind of interesting way of deploying services, because in the configuration mode where I let you specify a Git repository instead of a file path, I can translate tags into Git commits, which we'll see in a bit, and then you kind of start getting the ability to build CI pipelines out of this. Before I show that, I want to talk about something that I spent way too much time on as a sort of premature optimization, but it was an interesting thing to go through. And this is something that Graham kind of kicked off when he started building build layered image. So for historical reasons, Docker has a maximum number of layers that you can have in an image. It's around 125 for some reason. And it turns out that even using up all of those is not a very good idea because you share this layer restriction with your users. So if you have users that want to pull an image and extend it by adding additional files, you can't if there's already 125 layers in the image. So Graham had this initial idea of creating a graph of all the dependencies that a given image needs, and then counting the popularity of individual things inside of that graph. So if you have more than one derivation that references something like glibc, then glibc becomes more popular, and eventually you sort by this popularity and kind of pick the most important ones from the top and hope that those are going to match. But in this case, you have a maximum of one derivation or one closure per image layer. But there are many situations in which some kind of thing depends on, let's say we have a program called foo and it depends on foo data. There's never really a good reason to split foo and foo data apart from each other. So we want to actually put them in the same layer and make sure that we get kind of optimal caching here during the builds. So I'm going to walk you quickly through how that works, and there's a more detailed write-up for those of you that like graphs. Right. I suspect that some of this is not going to be readable all the way from the back, but I'm going to very quickly talk through this. So I had to find something that doesn't have a whole lot of dependencies to actually demo this. It turns out my initial attempt was to use Git, but Git depends on literally the entire universe and every single Perl package that exists. So that's a lot of packages. What we have here is you see a blue node at the top that's called the image root. And then there's a few arrows that go from that to the top level of this graph, which are images, which are packages that the user requested. Specifically here, there's htop, and there's nano, and there's a shell somewhere, and that's kind of it for this image. Actually, nano is part of the shell alias. And then if we look at this, there's a few interesting things in here. So for example, Perl is only referenced once by the more utils from up there. But Perl itself actually turns out to be a very popular package. There's a lot of things that depend on Perl. So we would like to use this information and kind of make sure that Perl ends up not bundled together with more utils. And similarly, we can see that glibc is extremely popular. It's got a lot of arrows going into it. So what I started doing at this point is together with a few people in IRC and also at work, we devised an algorithm for counting the popularity of all packages in Nix packages. By just checking how many runtime references there are to any given derivation, and then creating a kind of popularity metric by multiplying that with the size of the closure, so that we can get kind of the best cache hit performance in terms of data transferred and whatnot. So the way this works is that the red ones here have been identified by Nixery as popular packages, and we go and we draw extra edges from the root to those popular packages, which in the case of Perl, for example, now means that there are two paths going into Perl. That's the red one up here. And then we create what's called a dominator tree of this, which is a relayouting of a graph into a tree in which every node is preceded by the ones that all paths to it must pass through. If that was confusing, the Wikipedia article will explain it to you. That ends up looking like this, and suddenly we have a very ordered graph of how these things look. So we have the image root, and then we have a top layer, which actually matches very well with the images, the image layers that we would like to stick into the same tarball. And then stuff like more utils, which depends on some of these not very popular Perl libraries, relatively speaking to the rest of the ecosystem anyways. And we can bundle these together into the same layer. So once we get to this point, we can calculate the ideal layer layout, which looks like this. And then based on the budget we have available for layers, we can start merging the least popular things together. And then we actually get pretty good build caching out of it. Cool. Does this make sense so far? Is there anybody who would like to inject a question at this point? Right, let's move on. So what about image tags? One component of image names I didn't mention before is this yellow one here at the end. It's the image tag. For Docker, this is commonly versions that people add to things. So they will have something like Ubuntu : and then an Ubuntu release version or whatever. But I realized that we can actually use this information and map it onto something else, specifically Git commits. So if you're pointing Nixery at the public Nix packages repo, you could use this to get arbitrary references like specific channels or specific commits. If you're pointing it at a private repository, you can start having your CI substitute these parameters, and then you can use this as your deployment strategy. So to quickly show that, I will show you a demo involving Kubernetes, and this is going to be the one that will definitely fail, so wish me luck. Right. What I basically want to show, first of all, is the deployment manifest for my blog. So my blog, which most of you haven't read, and I don't really post to it, so whatever, but it's an interesting experimental playground for new technology. I have this Kubernetes manifest that deploys the blog. For those of you not familiar with Kubernetes, most of the fields in here don't really matter. It's just a kind of verbose thing. The primary line in here is this one here. It specifies the image to run. I'm going to zoom in a little bit just to make sure that people can see this. Where what's basically going on is that I'm pulling an image from nixery.local, which is a private DNS name pointing to a nixery instance running inside of my cluster. How to do this is something I'm currently writing documentation for, so people will be able to start doing that on their own very soon. And then I want the attribute tastion.blog, which is the derivation for my blog. And I specify the version as githad. So this syntax here is from a templating tool that I use called Contemplate, which basically just inserts the current git commit of the repository that you're in. Right, so what I can show you at this point is I can describe the deployment for my blog in Kubernetes. This is live speaking to the Kubernetes cluster in which I deploy my personal things. And we can see that the image is currently some commit in this Git repository. I can take this commit and look at what it is exactly, and I know that this is the one on which this particular image was built. So to do something a little interactive now, I have spun up Nixery inside of the cluster. Here's the live log stream from Nixery. And I'm going to, first of all, run a container inside of Kubernetes and attach to it interactively. And then we will do something more interesting. So the way this works here is syntactically very similar to Docker. So if you saw the previous command and understood it, it's pretty much the same thing. We're running a container, we're attaching a TTY, we're doing this interactively, we're giving it some randomly generated name because I don't want to conflict. We're not restarting it, and we're pulling the image from nixery.local/shell, so it's just going to give me the standard bash environment. Now if I run this down here, I will see that a demo container is now creating, and after a couple of seconds I get the shell out of it. Cool, so there's nothing in here as before, there's no extra commands. I'm not going to demo htop again. Instead, I'm just going to let you know that this Nixery instance is pointing at the repository I was showing you earlier, so I can actually go and pull the NixCon demo that I was showing off for a second into this instance and deploy a container with it. I'm just going to go ahead and do that before talking too much about it. And now we should start seeing messages from Nixery here. So let me just make sure that the stream is not dead. Yeah, here we go. So there's now a build happening. And if Domin is doing his job well and CacheX is up and running, then this should hit the binary cache. If it doesn't, it's going to be interesting because this is a Rust thing, and the Rust compiler is not the fastest one, and then I'm probably going to end up in a situation like yesterday with the Haskell demo. So let's give it a moment and see what happens. Actually, on the topic of caches in this case, what I found to be a very effective way of working with this is having a CI set up on your system that populates a binary cache, something like CacheX, on every push, so that all the things are already pre-built when Nixery tries to go and fetch them from a binary cache. Nixery can, in theory, go and start building everything from scratch, but you probably don't want it to be spending a couple of hours building your Haskell services, so it's nice to have that done already when you get to the point of deployment. What we're interested in here is not necessarily having everything pre-cached on an image level because we want to be able to dynamically modify what goes into an image, for example, by adding debugging tools, but it's still nice to actually have offloaded the caching of stuff like your actual service builds to Nix. Okay, here we go. The Nix build is done. A bunch of stuff happened under the hood, and now we have a command prompt here that should actually give me the NixCon demo. And now if I forward, let's see if we can get this to work. This is the one. If we forward something like port 4242 into this container, then I should be able to Right, that demo worked. I'm surprised. The trivial first one. Well, that's how it always goes, right? Cool. So Kubernetes is pretty much one of the ideal ways of using this in production, and it's kind of based of the origin of the idea where this whole thing came from. And the deployment of Nixery into a cluster is relatively simple. Like I was saying, this is going to be documented on my page. You basically just run a Nixery instance and add some environment variables to configure it. There's nothing really special about it. The one restriction that is in place at the moment, simply because I don't have time to implement support for everything, is that this only runs on Google Cloud Platform right now. There is a mode coming up for just being able to use a local file system instead of serving image layers from our storage system. And once that happens, you can actually run this anywhere. Also, contributions welcome if somebody wants to implement that. The issue on the issue tracker describes how it should work. Yeah. And then once you have that up and running, you can create these kinds of things to solidify the deployment infrastructure using this service. Right, that's kind of the primary things I wanted to say. Here are my contact details and where to find source code and all that kind of thing. Yes. And I want to say thanks to Sarah and EDEF for coming up with the broccoli alias, which we kind of picked up late yesterday evening. Right, questions?
So 2 questions. First, in the URL, you specify the path and you specify packages or derivations using /.
Yep.
Did you try to, or did you consider using Nix expressions there?
Yes, the primary issue is that there are restrictions in the Docker registry protocol on which characters are allowed, and it's quite restrictive. So for example, an interesting fact, there's an issue on the issue tracker about this. You cannot have uppercase characters in there, and Nix packages has things like Haskell packages, which is an uppercase thing, but you might want to refer to packages inside of that are actually binaries. So what I did is I tried to do a first lookup with the exact name that the user specified, and if that doesn't work, I normalize the casing of all attributes and then do a lookup with that. And some of you are probably guessing this right now. Yes, there are name clashes based on casing inside of Nix packages. Fortunately, at the top level, this only affects things that are actually aliases for each other, but inside of Haskell packages, there are actually different pieces of software with names that are only different in the casing. So for those, I just don't have a solution at the moment. If you need one of those, I don't know, make a private repo and alias it to something sane. With the original Kubernetes controller idea, I also considered adding a field just to straight add a Nix expression in there, but since that idea has kind of been dropped, I thought that it's probably more reasonable to actually keep those in the Nix repository rather than inside of the deployment manifest.
Okay, thank you. And the second question will be, how you set up private Git repository with it? Like, mostly I'm interested with the keys.
So I'm using the built-in's fetchGit functionality to fetch the repo, and built-in's fetchGit uses the SSH configuration of your environment, so it's impure, which means that as long as the environment in which Nixery is running is configured with appropriate SSH credentials, then everything will just kind of work.
Thank you.
Cheers. All right, anything else?
Perhaps I've missed that bit, but I wonder, the Docker file has a lot more to express like mount points, XX,
Yep.
whatever. Is that handled with Nixery, or do you have to build some kind command line
Yep.
around that?
So at the moment, most of those things, because they're kind of only metadata, are outsourced to Kubernetes. So you specify stuff like the entry point inside of the deployment manifest. There is an effort in progress in Nix packages right now to add metadata to every derivation that contains binaries that tells us what is the primary binary in this package. And once that is in place, we can actually automatically generate entry points. But then there's also a discussion of if somebody writes shell / nginx / ngrok, which one do they actually want to run, right? So at some point you still have to defer to the user. As for environment variables and that kind of thing, in theory, the Nix builder that we have to do this kind of stuff supports them, but there is currently no surface in the API where you can actually attach that. We might come up with something later. There's a few issues about related things on the tracker. Feel free to give some input.
Are there examples of other meta packages besides shell? And what can you do with those meta packages?
Yeah, so shell is the only one that the public instance supports at the moment. The next one that I'm currently working on is ARM64 to serve your ARM64 binaries. The thing with that is that the Docker registry protocol has sort of support for switching architectures, but it does it in the form of serving you one manifest that contains hashes for all architectures. So if you were to use that functionality, you would have to build all things for all architectures on every request, which is probably not what the user wants. So I'm thinking that meta packages as the first element are kind of a more sane way of toggling that behavior. All right, thank you very much.
So the last talk of this year's NixCon is going to be about building outside of the sandbox by Leos.
Like this one is working? Perfect. Okay, so hello everyone. I have this strange pleasure to be the last one to talk at this conference. But there is a talk that's precisely made for you to think a bit. I have no real message for you, or rather would love to challenge you and think about like what we do a bit differently. So I am known as Leius. I'm currently doing a PhD on build systems, so we can have a chat about that later on. And this is an experiment that comes from, well, some presentation that I made 2 years ago. So it will go in like very simply with 3 different examples. I want to build outside of the Nix sandbox, and I will use different tools to do that, like CKH, SCKH, ReCC. You will get explanation of that, and then we have a small discussion about, well, what does it mean, where do we go, and final conclusion. So 2 years ago, I was here precisely in front of you, and I had this, well, video. We didn't work at the time, but I think it's fixed now. Like, yeah. So this video basically shows what happens when you're trying to build a long package like Firefox. For me, it's often Firefox, but possibly you are building GTK or anything like that. And then you reach the top, nearly all of the compilation is done, and then for some reason, at some point, well, there is a fix-up thing that doesn't work, and bam, you are done. You are just back at the start. And if you want to fix the issue, then you have to pay all of the compilation of the full package. Well, so what's the situation now, 2 years after that? Well, we cannot build Nix package incrementally, of course, and that's because of the sandbox. So it means that for Firefox, GTK, LibreOffice, Qt, GCC, well, GCC is a bit specific, all of these things you have to build them from scratch every time you make a change to derivation. Possibly that's not something that happens often for you, but if you try to hack into the Nix package, especially if you want to like refactor the standard environment, something that you should never do, but if you work on that, then you will pay that you have to build everything. So my first attempt to escape this sandbox is CKH. CKH, I guess everyone knows that, no need to explain. It's quite an old tool, but it's still heavily used in some places. And the basic idea with all of these caches is that, well, you already asked me to compile this file with these options and with these headers, so I already know the answer. I can just fetch it from the cache. A small picture, right? So just query the cache, and the cache says, well, no, it's not there yet. Okay, so you can compile locally, and then you upload it to the cache for the next iteration, and then you get your result, right? Which means that on the next time, when there is a cache hit, you can just recover the result from the cache, and that's it. It should be quite fast. Okay. The funny thing is that I say, well, I want to try that, and then I discover that it already exists. It's already feasible in Nix packages. There is a CKH std-env. That's a standard environment modified that allows you to use CKH. There is a lot of wrapping going on there. We can have a small chat about what that means, but basically if you replace the standard environment with that one, you get CKH working. Well, you get CKH working, but you still have the sandbox, right? So we'll see how to get out of that. But in Nix OS, that's also already provided, and then it comes with all of the defaults that you need to change into Nix, meaning that you need to build by allowing an extra folder, the cache, to be mounted inside the sandbox. And Nixos will do that for you. If you are just using Nix, then you have to use options to do that. They made it in, I have no idea who did that, by the way, I should check. But they made it in a very smart way in the sense that you can specify a list of packages that will have this CKH enabled, so that you're not breaking the sandbox for everything, but only for these very heavy packages that you will compile often. So if in your company you have one big package like that, you can add it to the list. Okay, let's try the demo then. So the demo will work. I've taken i3 just because it's an average size C++ project. And we will build that normally and then with CKH to see what it gives. Okay, let's go. Yeah. Okay, so if I want to build i3 normally, I just Nix build this i3 stuff, and we will try to get that into, we will try to filter the output. So it's been modified a bit. Just checking that everything. So it's been modified a bit because I've added some kind of debugging to it. So you can just see the time that each phase takes. So we get this unpack phase, like, well, that's way below the second. The patch phase, way below the second too. I expect something about 10 seconds to build. Yeah. So you have 8 seconds to configure and 10 seconds to build i3. That's with the sandbox. That's everything's normal except of this extra logging added. Now, if we start with an other tool, we can Nix build a i3 CKH. Yeah, CKH. If I do it like that, then the sandbox is still active, so it won't change anything, right? So you need to add an option that's an extra sandbox path. With that, I can build and mount the CKH inside the sandbox. Well, I don't want to do that at the moment because, well, this cache, we will try to clean it before. Okay, so just to be sure that there is nothing in there on the first try. Okay, we can start compiling it. And of course, I'm still missing that. I'm not sure if you have an idea of what's to be expected, but in this case, there is nothing in the cache. So we need to compile everything, so we'll have to take the same time. And also, we have to pay an extra overhead for serializing and inserting everything into the folder. So this should be a bit slower, actually. Okay, so now it's 10 seconds and 15, so it matches what we had before. Like we are from 8 to 10 and from 10 to 15, just because we pay the overhead of initializing everything. So if we want to start with we need to compile it again, right? So I made a special trick for you that you can just say again to the package, and well, I can't explain you how it works, but it's nothing very magic. The nice part is that, well, it starts the exact same compilation with some random stuff added to the derivation, so that Nix thinks that it needs to be done again. And this time it's supposed to be faster. Modulo demo effects. Well, okay, that's not exactly what I used to have, but it makes some sense. So, okay, right. So we have all of these. If you don't mind, I will take the old results that I had. They're basically the same, 7 and 6, right? That's what we had, 7 and 6. So it's like, the rounded numbers are the same. So, well, nothing unexpected here. Except that, well, you see that there is this 6 seconds that's below the previous build times, and in a sense, i3 is not a tool that uses heavy GCC compilations. There are a lot of manual generation, documentation, generating a lot of random stuff that are not cached by Ccache. So of course, on a bigger project that uses more C compiling, you would have a better speed up here. But possibly you would also have a higher penalty on the first time that you use it. Makes sense. Well, is this a good thing? Yeah, the problem is that when you start to make holes in the sandbox like that, well, you know, you don't have any guarantee of what's happening, right? A small hole in the sandbox and that's over. But at the same time, and we'll have a discussion at the end on, I think it can be a good thing, at least in some well-defined situations. Anyway, let's go to the second attempt. So like I wanted to use, well, Ccache, that's good, but no, well, now people, they do better things at that. What if I want to use the same cache as my colleague or someone else? We should put that on the network. And that's basically the idea of SCcache, which is Ccache shared, or shared Ccache, developed by Mozilla. Well, so it's Mozilla, so they made it for C and C++, and then they also added Rust because, well, it's Mozilla. And if you look at the diagram, it doesn't change much. It's just like, basically it's exactly the same. The only change is the name of the cache. It's not a folder, now it's a network machine. Which means that you are not mounting a folder inside the sandbox. You are making a completely different type of hole in there. You need network access. Well, is that possible? No. No, it's not possible, it's not supported. You cannot make a small hole and say, okay, I want this machine, I want this port on that server. It doesn't work. So at the moment and for the experiments, what I do is just disable the sandbox. So we are entering strange countries. But technically, it should be feasible to have like a restricted network access in the sandbox if we want to keep some of the properties, but not all of them. Yeah, I also discovered that the sandbox is not, like disabling the sandbox is not possible when you are building a different store than your main store. So all of these demos are just changing my main Nix stores. Possibly it breaks things, but we'll see. Yeah, okay. Disclosure here. I won't do it because, well, for reasons that we don't have much time, and also because it's not that different. Just disable the sandbox, configure the remote, and that's it. So I will go directly to the third attempt, which is ReCC. And ReCC, we keep the same ID, except that we had remote execution. That's a tool that has been developed at Bloomberg. And they do it mainly because, well, they love Bazel. They would like to have all these remote execution and things, but they can't move at the moment. Like migrating all of your builds to Bazel, that's a huge investment. So they don't want to do that. And they developed this very small replacement that's, instead of changing all of the build system, you just wrap each GCC invocation with it. And then at that moment, everything is sent to the server. Well, you get a better explanation with diagram. But what we do in this case is that we remove the local compilation and everything is remote. The main advantage is that you can parallelize a lot more. If you have like 100 workers and a huge workload, then you can spread the workload on 100 workers. That's the main advantage of not executing the compilation locally, of course. Okay, so this is the example that may not work perfectly. I discovered that you need, of course, a server that allows this remote execution. So in this case, it's build grid. I could have used another one, but I discovered different issues. Not sure if it's Nix related or like my VM related or something, but I cannot work in parallel. So I can only compile one thing at a time because the server won't take many attempts at the same time, which is like a bit stupid. It's not a limitation of the tool. It's used perfectly well in a lot of companies, so it's most probably an issue with my setup, but anyway. So it's single threaded, and then the worker is quite slow. So if I had to do the demo for you, Well, that's the time it takes. It takes about 3 to 4 minutes to compile now. Well, there is definitely some issues. So, nevertheless, I think this is mostly like, well, bad configuration from my part. But I really want to show you what kind of strange things you can discover when you do that. So let's start again. So if we this is completely stupid. Like, it's a build grid server, but it's called build farm. Well, we have to live with that. So now on this server, everything is already compiled, so we will remove what's in there. I remove the content at the store that's on the server. I remove the database, so there is just basically a clean server anyway. And I start the server. I also need to start a worker, of course. Yeah, that's initialization. And then because I'm lazy, I did not specify any kind of Docker worker or any environment. I just like use whatever is on this machine. Well, that's it. And now, can we make this smaller? Okay, right. So what we want to do now is build exactly the same thing as we did before. Yes. So it's Nix build. Okay, we want this i3 recc. I will take the recc small, well, whatever. This one should be built already. Let's try. Option sandbox false. This is what allows you to access the network. Yeah, it's already built. That's good. And the next is also already built, I guess. Yep. So we need to go over and over again. Yeah, okay, that's working. Very useful when you have to build a lot of things like that. And, well, no, I won't say you. Let's see what we get. It fails. It fails, and that's normal. That's what you get on the first attempt. If you're like, there is nothing on this remote host, you need all of the build inputs. All of the dependencies of your derivation needs to be there in a way. And this is, of course, not automated. It's not, doesn't work at the moment, but then I think there is some potential to make integration and to make Nix catch the network access and wrap it in some way, or we should be able to find a way to make this work. At the moment, what we have to do is like upload the inputs. So, oh crap. So I just try to collect all of the build inputs of my derivation, and then I send that to the server. Well, this is a trick. There is always a trick. Like, the network is not that good that I can upload everything, but I just removed one of the missing files, and this is the one that has just been updated. So if we start again and build this again thing, what do you expect? Does it work now? Well, can we wait? It doesn't work. The tool is still missing. How is that possible? We've just added the tool that was missing. And in this case, it's like one of the most frustrating parts of this is that, well, the failure is already in the cache. So we're just fetching that. He says, previous time, it failed, so I can fail again. If you want to work around that, then you need to kill everything. In this case, I have no idea how to remove one entry, so just let's be efficient. Okay, everything started clean from scratch, so now I can build it. And, well, of course, it takes like 3 minutes, so we won't wait for the end of that. But this time it should work. Let's wait. By the way, this recc-small is configured in a way that the cache VCC is not used in the configure phase, because the configure phase just drops a lot of the output, and so you don't see the error that we had before. That's the reason for the dash small in there. So it's working, it's compiling one thing at a time. Well, it will compile for 3 minutes. I don't really need it because I have everything in there, so let's drop that. Okay. Okay, makes sense. So like you've discovered, like we need to have all the build inputs on the server. Like it does not exist at the moment, but the fact that it failed is also a good thing. It shows that if you are missing the exact compiler that's required by that derivation, on the worker, it will say, I don't have it. He's not trying to use another thing. He's not trying to use GCC that's installed on that machine. So Nix, by design, with all of these strange paths and hashes, makes it so that you do not pick random stuff. We've discovered that like these impure errors are cached. The fact that there was something missing in the state of the worker, like this is there forever. That's really annoying, so, well, that's something to care about. But I think we could really automate that. And, well, the gain is potentially really huge, because in Nix, if we can have the real exact set of inputs, we could share this information through everyone. That would be like an Hydra cache for very small C file builds. Well, now there is a question of like, well, this is not pure, right? Or we've broken everything, the balloon has exploded, so the sandbox is no more. What remains of all the good properties that we had with that sandbox? And so like, well, is it still reproducible? Is it still pure? Is it still hermetic? And all of these nice words that we are used to and that we absolutely want in our builds. And for that, I have a small answer that's based on Nix experimental. What I call Nix experimental is like it's an experimental branch from Elko, where you can transform a derivation into that's difficult to say. Well, the problem with most of our derivations is that we have plenty of them that look the same. They have the same content, but because they come from a different .drv, they are stored in a different store path. And then that store path is inside the binaries, inside a lot of places, and then if you compare, the bits are different. But we can do something that's funny. So let's find I3. So this is the one that we built before, so it's there. If you go to Nix, of course it's a local checkout of Nix and another one because I had to build a different branch. Okay, let's hope that it works correctly. Yeah, you have a lot of outputs in this case. Possibly if I reduce the size, that's still readable for everyone? Okay. Well, in this case, you have a lot of random stuff. Let's just cheat a bit. There is a mismatch between the daemon and the Nix that's running, and well, they don't agree on what we are trying to do. But you see here that this is the path that we received, and this is what it looks like when it's been content addressable. So basically, all the closure has been rewritten, and the name of the path has been changed so that it matches the actual content of the path. That's the meaning of content addressable. Of course, there is a problem because paths, they reference themselves, and you need to compute the hash on something, and you would never end. So basically, you just remove self-references, compute the hash, and then reinsert them. And so it's not perfect content addressed store. It's like content addressed modulo this self-reference. What's interesting in there is that if everything is working correctly, this I3 C cache thing that I built, it's still cached, okay? It has a different hash, but if I make it content addressable, yeah, if I make it containerized, then you see that you get the exact same hash here. And this means, and we can check that, but it doesn't make any sense because it's the exact same store location. But if you try to diff these two things, you will see that there is no difference. Well, that's obvious, but you can try if you want. And of course, the one that remains to be tested is this ReCC. Yeah, small, or whatever. And that one should also give us the same output. Yes, that's working. Well, in this case, you may not believe me because it was already in the cache before. But trust me, you don't want to wait 5 minutes just for that to build. So that's kind of part and answer. We have broken everything. There is no sandbox at all, and we still manage to get the exact same output. Right? So this sandbox is not like, it's not totally needed. It's there to guard you against making mistakes. It avoids typical issues. It avoids the network if something is trying and you don't want it to try. But if you configure everything properly, then it should build the same outside of the sandbox or inside the sandbox. And in this case, like you have different derivation, you have different contents before, and then like this is the image that was there if there was some issue with the demo, but I guess you got the idea. So what we have now, it's a bit like before, but well, you know, you compile Firefox, it takes a lot of time, you see that it's making progress, you've done most of the Rust, and then C++ is over, and you will enter the fix-up phase. And then, oh, it doesn't work. But then you are not back from scratch, right? You can recover some of the work that has already been done. So that's better. Yeah. So just a few messages. Well, this presentation is not about like sending messages. It's more like challenging. So I would like to get feedback. If it gives you an idea, that's perfect. But like the main message is that you can bridge a sandbox, and it does not mean that you are doing something wrong, but well, that you should know what you are doing mostly. It's really nice when I see that. I'm like, oh yeah, it's going to work. We will get these incremental builds inside Nix packages, and that's something that I really want. I think it will also be really useful to get fast CI answers. So if you want to make a pull request to Nix packages, then you could get the answer within like a few minutes and not a few hours. And also, like, it also means that we can trust other tools. Like ReCC is doing its best to make it like reproducible, hermetic, and all of these nice properties. Ccache is doing its best, but it's very old, so it doesn't know everything. And then these tools, they are just C compiler abstractions, but they behave exactly the same as like ReCC behaves exactly as Bazel, for example. So it's just that ReCC manages only one C compile, but Bazel manages a set of files. From the outside, meaning from the Nix point of view, it's exactly the same. It's a tool that's trying to execute something remotely and get the results. So if we go that way, we could consider trusting Bazel, for example, for doing things purely and correctly, and allow it to have access to a cache and a remote execution engine somewhere. So that's it for me. I have questions for you if you don't have anyway, so think about one.
What about verifying some compiler cache instruments for reproducibility so that they can be really trusted and not just relying on limited amount of experiments?
Well, I guess that's always the same thing with reproducibility, that you have to test it, and every time it's reproducible, that's good, but it's not a proof that it will never be reproducible. So we can do that with these tools too. We can just start to include them and then compile a few times, and then once in a while just make a perfectly hermetic sandbox build from scratch and see if we are still building the same thing. And that would give us more confidence that the tool is working correctly.
I mean, maybe the problem is that when these tools had been designed, there was no thought about such thing as reproducibility, and it might depend on different things like system clock, for example.
Well, truth is, I am not aware of all the subtle details of all of these tools, so that's something that we'd have to explore. It's like, look, it's feasible. Does someone want to work with me on that?
So one idea came to my mind when you showed mounting the file inside. Did you try to mount like Unix socket, maybe, I don't know, Ccache and sccache very well, but maybe you can try networking that way?
I tried, and then I had no more time. So I think that theoretically it could work, but I don't know enough about all the technology details. From the outside, it looks trivial, and then when you try to set up everything with the namespace and stuff, well, it breaks easily. So that's something we can try tomorrow. If you think that it can be done in a few hours, then I would really like to try.
Cheers.
There is
Hey, first I wanted to say I really appreciate, because I've been many times in the situation where I wanted to package something large like Ceph, for example, where also iterating on bugs. Building Ceph takes 1 hour. I had to build it over 80 times, so you can imagine that took a while. So I really appreciate any effort in going in that direction. Same thing with Haskell, which when you work on GHC, for example, or iterate on a low-level library and rebuild Nix packages, can also take a very long time. So I think this is really good. I wanted to also point out another approach that is like a little bit orthogonal to what you've presented that we just discussed yesterday here at the table with I think edevpi and me, so NH2, which was that you can also do the type of caching that Ccache, for example, does specifically for like C things, right, on the syscall level. So we could, if we wanted to, p-trace the entire build and then see that if, let's say, an execve produces certain output, we can cache that and then wrap any execve call that happens again to produce exactly the same output again. So that is, of course, somewhat in the further future, but that might be something that can be very generic across multiple things. I think practically, I will first go with exactly this approach because you have now shown that it works and it's great, and I just need to see how one can get the same thing for GHC Haskell, for example. But in the long term, that might be something that if we agree on enough, bringing enough hackiness into this thing as a kind of like quick developer thing, we might do as well.
Well, it's not really a question, but I have still 2 answers for you. Well, it's funny because I had the exact same discussion with NBP like last year and the year before. Like, well, we could do that on the syscall level, that would be fun. Through this, it's not that easy. You have lots of cache entries and etc. So you need to be really, really efficient. So it's a cool idea, but I'm not sure it will turn out practice. But I'm always available to talk about that idea. Thank you.